understand that I don't wanna play your game.
The Earth is very flat.
What's going on, everybody? It is Wednesday, July 7th, 2021. This is Brandon, host of Brandon's Show. Welcome to the show, everyone. It is raining like cats and dogs here, just in case anybody wondered about the weather where I'm at. So now you know. Paul Cruikshank, what's up, man? Karem, Cleary, page 42. Bill G coming in first again. Keep it up, Bill. Dan Morris, what's up, Dan? What's going on, guys? Dan says the music reminds him of underground clubs I frequented in my youth. Yeah, kind of reminds me of a couple of raves I went to as well. I hear you there. I wasn't a big raver, but I did go a couple times. Not really my scene. Weird stuff. Anyway, we got some stuff to look at today we didn't get to yesterday. A particular picture that was in the thumbnail that has been put forward as evidence of the glob Earth. We'll take a look at that. And then we might talk about J-Trig a little bit and see if the description matches any particular people we know. And we didn't get to that Challenger disaster video from, what was it, Level Earth Observer? I might have screwed the name up, but we'll try to get to that today, this week sometime for sure. And who knows what else. But anyway, let's go into Discord, see what's going on.
Some water. You're not containing it like a popsicle on a stick, buddy? Whatever's dick.
Yeah. Why are you stuck to the...
Whatever, man. I believe in bullshit.
Why are you stuck to
Whatever has nothing to do with reality and freezing stuff at all. So
well,
let's
we've seen solid objects contain other objects, so it's not too metaphysical to say that a solid object like a solid firmament dome of sky is probably containing it.
No, I'd say a temperature. And there's a cold frequency as well as there's focused hot frequency, because you have to have the opposite.
Temperature is described as basically the motion of atoms, which basically reduces it down to something else does.
No, there's no atom. There's no such thing as a fucking atom. There is temperature,
then
though,
how
buddy.
would you describe temperature? How can temperature contain unless you have atoms that are colliding or bumping or whatever?
Lemon, is your atom a sphere?
And the current conception,
I think
more
it's
or
too
less,
dumb.
yes.
So in the current retardedness of the rhetoric that you imagine, an atom is anything I can draw. I draw my atom as a unicorn.
Now what?
We've seen solid objects
The
contain.
question is now what? How do you follow up a statement like that?
How do you follow up physics with physics?
Question. So I'm just
Go
going
get
to move on.
education.
If you answer my questions with a question, that basically means that you don't have an answer.
Freeze gas,
So I'm
freeze water.
What's going on, guys? We're live now.
Hey,
What's happening?
Talking about freezing stuff to contain it, Brandon.
Freezing
He
stuff to
tried to say
contain
that
it.
temperature
Okay.
could contain.
Oh yeah, cold is a temperature.
Well, Lemon was trying to talk, but he was getting talked all
It's a
over.
container.
Huh.
He's trying to say temperature is a container, and I was trying to basically say to him that seems incoherent to me because something else would need to have a temperature for containment, which goes back to like a solid container as far as I'm concerned.
The liquid nitrogen above your head got a good temperature.
Anyway, how's everybody doing? Let me just go through who all is in here. We've got Chad. What's up, Chad? DRW 69 miles 0 degrees. Oh, is that you? Shit, I forgot your name all of a sudden. Democ, thank you. Extreme Assist,
Oh,
Farming Ganja, Flat Earth Egypt, Geo, Jeremy, Left Lane, Paul Baker, Pebble in the Pond. What's up, Pebble? Lemon, Rob on the level, Keen, and Shines, and Stu Unger. What's up, guys?
Hot in here today.
Hot in there. Oh, it's raining like a frickin' cats and dogs here, I guess. But anyway, I want to share something with you guys, a proof that was put forward by one of our resident chat trolls as evidence of the sphere Earth, and get your opinion on it. And I won't say what the argument was. I'll just show it on my screen. You should be able to see it now. And you tell me what you think the argument was and why this picture proves in this person's mind that we live on a sphere.
Under being lit.
Yeah.
Can you guys see it?
Yeah. Is it the clouds being lit from underneath? Is that it?
Yeah, that's one of them. But here, I'll give you the full argument. The full argument is, how do you explain the clouds being lit on the bottom and the top? Or a dark, I'm sorry.
Our argument or theirs?
Lit on the bottom and dark on the top of the clouds. That was the argument.
The sun. Next. I answered it. Now we can move on now. That's my answer.
That's a good answer.
Medium. Thickness of medium. The first cloud is real thin towards the light. It's going to light up. The thicker they get towards you, the more they're going to block the light. Next.
There's actually a huge problem with the question, with the claim that was made. The claim was that they're lit from the bottom and dark on the top. Does anybody see what the issue with this statement is?
I don't see that in the picture. I see the flat clouds that you're facing look dark, and then the clouds underneath of those look.
Is the light bending in between the? Is the light bending in between the clouds and the sun?
I don't know.
Light widens, we know that.
Where is the sun in this picture?
Far away.
Down that way.
It's probably behind you.
Well,
They act like they forget about.
I'll tell you what the problem is with the claim. You can't see the top of the clouds. So this claim that the top of the clouds is dark is pretty lame, in my opinion.
Exactly.
All you can see is the bottom. So you've got a picture of some clouds that are lit here. They're lit here, and it's dark closest to you. Why exactly would this be proof of a globe? That's what I'm wondering.
Even if the cloud was light on the bottom and dark on top, at best, it's an affirming the consequent fallacy. At best, I guess his fallacy is better than nothing, right? Right, left lane? Or no?
Because imagination is a globe. Case closed.
Oh, they don't care about logic anymore, you guys. Fallacies is for flat earthers, remember?
Oh, no. You're looking at their globe right there. Look at it, Brandon. Look at the glory of their globe right in front of us. I love their globe proof. Look at it. I don't even see nothing.
Open.
Yeah, this argument is particularly weak. I just wanted to point out how extremely weak it is. Now, what I see is clouds dark close to you. I see clouds lit that are closer to the sun in a pinkish hue. Some darkness over here. These ones are more lit, obviously closer to the sun. I don't see a problem with this at all. It's just some fucking clouds.
I see the best globe ever. That's the most awesome working globe I've ever seen in my life. I love that globe model.
What do you think, Left Lane? You think this picture proves the globe?
He doesn't know shit.
Well, yeah. Hey, Jeremy, I don't know what's up your ass about me, but I hadn't done anything to you, and I took a little bit more out of you.
It's not you.
It's all the
Globers.
Acting like,
yeah,
you're only hurting yourself acting like this.
Yeah, it's all the Globers. You're all full of complete horse shit.
Well,
don't take it personal. Don't take it personal. You guys are just full of shit.
Yeah. Well, Brandon, I posted a picture in chat that I think better represents this situation. Okay. I mean, you can see the clouds are obviously underlit. There's shadows on the backside of the lit clouds, and it's obviously because the light that's coming to that cloud is coming from an angle such that it's illuminating the bottom side of the cloud.
Is the light bending between? Is the light bending between the sun and the cloud?
Sure, a little bit.
So how do we know where? Plus, the sun's only in an apparent position. You don't know where anything even is, or what the light's doing, or anything. This is
light
fucking
does
nonsense.
bend around an obstacle, so the light could skate to the underside of the cloud and diffract under it, giving it some sort of underlit factor. Also, where light and darkness meet, you could have a gentle wash of illumination that makes the light basically like a fluid that fills the container, and objects could be submerged in this zone of illumination, top to bottom. But it looks like the Globers are saying that it's straight line rays of light that can't diffract under a cloud or spread out like a spotlight or a V. So you could have the point source sun, and then the light could V out and spread and skate the underside of the cloud quite easily. So I think we have a couple possibilities here.
So when Lemon said that I was...
Oh, go ahead, Leftley.
Lemon made a comment earlier that I was incoherent, and then he says that shit.
You guys always accuse him of being incoherent. I listen to him and I never think to myself, he's incoherent. I think people get tired of trying to think because it's difficult for them. So instead they just zone him out and then accuse him of being incoherent. That's what I think.
Well, Left Lane, you could be
they
correct, but I think the thing that basically convicts you in my book is that you didn't ask any questions. You just moved to dismissal, so I'm going to have to dismiss you in turn since you didn't ask any curious questions to parse out what, if anything, I meant. So have a nice day.
Oh.
All right, Lemon. Okay, buddy.
That's a good comeback. You know what? I don't see a problem here, but let me ask you something. If the sun is coming at this supposed angle where it is beneath the cloud, shining up on the underside of him, why is all this dark over here? It's just lit right here, like it's just the edge of it. That's what I would expect when you have a bright light source to the one side of something. You're going to get some reflection underneath off of water, or what's down here? Water, ocean, the ground. There's nothing about this picture that says to me we have to be on a ball.
At all.
At all.
The ground looks quite...
Do those clouds on the left side of the picture not have line of sight to the sun, or what's going on? Aren't the clouds supposed to be curving? I feel like all the clouds should be able to see the sun, not just that little portion over there.
Yeah, geometrically, if you're saying that the only reason that this right here, this yellow part is lit is because the sun is shining at such an angle where it's hitting from underneath it, then this part should be lit as well, right?
Sounds about right. Why aren't all the clouds lit? Hold on, Democ. Why aren't all the clouds lit on the bottom left lane?
Because
where's
of the
the
cloud
sun in this
blocking
picture?
the light.
Where's the sun in the picture?
The sun's below the horizon.
We don't know where the sun is in the picture. I assume it's off to the right.
Yeah, we have to assume because we can't see it that it's somewhere in a direction such that it could be lighting the bottom of the clouds.
Straightforward like the train tracks, baby. You're one rail, the sun's another rail. You're never touching, baby. That's what I assume. The sun's not going under shit. It's not even touching that other rail you imagine it's touching, going around and under.
Well, this idea that light is a straight line string that's just going to hit the cloud at a certain angle is a little off. Light spreads like a V from the point source and could potentially underlight the cloud once it spreads out from the source via dispersion. And so there's other theories of light we might have to go with here to explain what's going on.
How about light can do what it wants? How about that?
Well, we're trying to explore it in a way that gives us actions that allow experimentation and discovery. So we need to say meaningful statements that allow us to
Well,
guide
then we need the
toward
whole picture, not
experimentation
just
and
one
discovery.
pixel of like a real big picture.
So, Limit, if you look, and you're not supposed to do this, but if you look at the sun and you see the sun and the light that's hitting your retina, would you not say that the light that's hitting your retina came directly from the sun in a straight line?
I would say that it came in a straight line, sure.
Well,
But your retina's not a straight line, is it?
If we're gonna go with light straight lines,
Your
then
retina's
you
a
lost because the black swan kills you. So you want to go with lights traveling in straight lines or no?
well, we always consider refraction, Jeremy. It's been talked about to death, and it's kind of understood, you know.
But the way that they talk about refraction is very contradictory. Refraction usually happens.
Just show it in your backyard.
Yeah.
Show us some refraction in your backyard, how you have a hill in your
storm.
backyard and you have an object on the other side of the hill, how you refract it forward over the hill. Just show us that live.
Well, when you look at a straw, you can see the definite boundary between the air and the water splitting the image. They're claiming refraction, but we're not seeing a split image here. So it's just kind of question begging without full, evidence, presented like the split image to show that refraction is actually what's occurring.
That's a flat image. That's a perfect mirror flat image. That is not a curved image. Try again, ballers. Welcome to Flat Earth.
What refraction has to do
That
with
makes sense.
splitting the image?
When you look at a straw and the refraction from air to water, there's a definite marked split in the image. You're claiming refraction with no split. Sure,
No,
refraction
they are
occurs,
infinite.
but we do not have evidence that refraction is occurring with
Yes, we do.
a split image.
We also don't have a
Split
spherical image. The
The
image to be
gradient.
there has to be spherical some way or shape. The image is perfect. It's a perfect flat mirror image. Do you get that, Chike and Bio and all the Glovers? You understand that? No spherical mirror anywhere. Where's that at?
Also,
No,
at the
wait, Lemon, I was about to answer you and this idiot rumpused me. So we have a gradient of air and it's not a split image, it's infinite split images.
Where's your infinite bend? Where's your infinite curved image? Chike that floats. Where's your floating infinite curved boat?
Yeah, Debunk, you're really not making any sense. I don't even understand what you're saying.
No, listen, man. You're saying a mirage is a mirror image that's floating and bending around spheres, and then showing you the boat back at your eye over the fucking sphere, and that's not the boat it's showing you. It's a reflection, and you don't see a bent image of the boat. It's a perfect, flat, straight, exact, perfect square image. Like if you're looking at another picture of the boat, how can that be on a sphere, man? Show me how a sphere mirror ball looks with a boat, and then show me how a flat one looks, a flat mirror with a boat, and you see how much sense you make.
Yeah, so what happens is Demo cure a word, then he spontaneously, it's a reflex, he start talking, something around it. That's all.
What did you mean by infinite split images? What are you talking about?
What Lemon said, when we have water and air and we see the beam is like split. It has a definite place where it curves, right? Where it breaks from one angle to another. But we don't have water, we have air pressure gradient. And between every section of this gradient, there is a little bend. It's not a big bend at once, it's many little bends that accumulates to a curve.
What is your image of how light is getting to us? What's your conception of it? Is it rays? Is it little what is it? Photons? Little tiny pebbles that are shooting across at us? Or what do you think light is?
It doesn't matter.
No?
I would say that it's a wave and ripple in the medium of the ether. So we would have to be in the medium first for the ripple to reach us. That's why at the boundary between media you see a marked split, reflection, miraging, evidence that we don't see when we're seeing extremely far, almost as if we're in the same medium over a flat plane, just seeing the object.
Yeah, I really don't know what light is. I find the idea that it's tiny little photons that are shooting around and bouncing everywhere to be kind of ridiculous. I don't know that I've seen the evidence that that's true, but
They say that photons are a packet of energy, but when I hear that, that's like a slice of cake. It's an arbitrary division. It doesn't really have an essence in and of itself beyond the way that you cut it and you slice it. So since photons don't appear to have an essence that's concrete, I'd have to go with another conception.
I mean, we understand how things work that you involve light and electromagnetics, radio, X-rays, fiber optics. We can engineer those things. We have to know a little bit about what we're doing.
yeah,
We might be able to learn more with another conception. That's why the base conception, the base philosophy is important because it dictates other experiments, other actions, other engineering.
But everything that we do with EMF and things that pertain to light and building lenses for cameras and telescopes, it all works. So what's wrong with it?
Not just
Does
that.
it work because of the theory or in spite of the theory? People are pragmatic. They make it work even though verbally they say it works one way. They may practically be treating it like it works in another way.
Radio and as I said, X-rays. Those are examples of other things that if we didn't know how they worked, that stuff would not work.
For instance, we talk about radio waves, but a wave is usually defined as a disturbance in a watery medium. So if we're not talking about the watery medium that gives us these radio waves, we're not talking about anything that's intelligible or intuitive anymore. We have a really questionable theory at that point where we're talking about it like a wave, a ripple in the pond in one instance, but treating it like it's going through a vacuum nothingness in another. That's cognitively dissonant.
No, it's not. Words have different definitions for different contexts. You know this.
If the words are
I can wave my
unintuitive,
hand
they
too.
destroy understanding. They do not foster it. And
I can wave my
experimentation
hand,
grinds
Lemon.
to a halt.
Is me waving my hand the same as waves in an ocean? No, because words have different meanings for different contexts.
That's not quite true. It would both be a wave of the hand in action of something and a wave of the pond, something that something does. These radio waves would be something that the medium of the ether would do also by a similar intuitive definition.
This is a perfect example, Brandon, of Lemon just spewing shit. I know that you understand that words have different definitions for different contexts. This would be a great example.
So without
What's
an
the context
intuitive
of
language,
electromagnetic
understanding
wave?
stops.
What's the
The
context
original
of
conception
electromagnetic
of the
wave?
ether was the original conception of the ether was to explain the electromagnetic fields that we observe in reality.
What do you picture when you talk about frequency? What do you picture?
Oh, I don't know. Physically, I don't know. It's hard to describe. I understand that we can measure
we
frequency.
describe it as a wave.
I understand that we can measure different magnitudes.
Down, right?
I understand that we can measure different magnitudes, different frequencies, and at different frequencies, different things happen. I understand that part. But when I think about it physically, I don't know how to describe it. No.
Well, how do we always represent it, though? How is it represented on an oscilloscope?
Like a wave, yeah, of course.
yeah, that's really why I brought the subject up. I was just wondering if what Chaiki's how he imagined it physically as little particles traveling in a wave or rays that change direction or so what is happening with refraction if it's waves and it's kind of going up and down and as it goes forward that whole
So the idea of rays, the idea of using rays is just a way of approximating the propagation of the light wave. So when you talk about rays, you're talking about length scales in which the wavelength of the light wave is very, very small compared to the length scales in which the light is propagating. So it's just a way of, basically you can think about the rays as being perpendicular to the wavefronts of the light waves, basically.
Okay. So it's just a tool to help you conceptualize it, think about it.
Yeah, basically. It's like an effective description, but it only works in very long distances.
It also appears to match reality. When we pass light through a grating, we get a wave that does look like a drop in the pond, almost as if the light is a wave ripple in a background ocean-like medium of some sort. So it also appears to match very closely observation, almost as if it's real.
That's why a lot of people
provide
at the
evidence.
beginning of the 19th or the 20th century thought that there was an ether, and there were predictions that can be made based off of that, and they didn't turn out to be true, which is why we don't have the ether anymore.
They expected a 30 kilometer per second ether drift if the Earth was moving. But if the Earth isn't moving, then the 5 to 8 kilometer second ether drift that they were clocking could be explained with an ether moving more slowly over, say, a motionless, possibly flat Earth.
Or those measurements were within the margin of error, and as that margin of error became tighter, so did that measurement.
Or heliocentrism is bunk, and they're trying
Why don't we talk
to
about?
keep it afloat.
Has anyone looked at detecting ether since Michelson Morley?
They've actually done the Michelson-Morley iteration many, many times since then, and that's what I was referring to, is that their margin of error becomes tighter as technology progresses and it advances. That same measurement that Lemon likes to bring up has gotten smaller as the margin of error has decreased, but it's always falling within that error.
Yeah, that's my point.
But regardless of whether or not the Earth is stationary in its ether, you can still use the current understanding of light, assuming an emotionless Earth and some sort of background ether, if you wish. And the description of light, how it's traditionally understood, would not change. So, calculations that are done by Globers to include refraction should be accurate on a stationary Earth with a universe reference frame that is defined through the ether.
Oh, okay. Interesting.
They're only calculations. It's not when they think. I know Left Lane just said it. They all think they know how refraction works, but they don't. They can't prove it. They can't prove it. They can't.
Yes, we can.
If you knew, you would be able to prove it, and you can't.
Prove it, Brenda. Do it.
We can prove it. It's a measurement.
Right, do it, Brenda. Prove it.
It's not a measurement.
Refraction is not just a function of light waves. It's a function of any wave that's moving that has a varying wave propagation velocity. So if you have a material which has varying density, the sound waves will actually refract in that material, and you can measure this.
Well, the problem is looking at light like a string that bends. Light appears to have more qualities than just a string that bends, like that laser in the sugar water. For instance,
is a string.
They treat it as if it is. When you're looking at that laser in sugar water,
Nobody
treating the light.
Nobody treats light as a string. Lemon.
Remember, I just said the refraction calculation of light rays is a tool for calculating the propagation of electromagnetic wavefronts through a medium. It's an approximation of electromagnetic waves. You can actually use the ray. You can use the ray calculations for other mediums like sound. It would work just the same.
Because in real life, when light does reflect off of media, we see a mirage or some sort of split in the image. But then they drop that philosophical take on light as some sort of, bouncing reflected mirror that matches everyday life, and then go for this stringy light concept that matches more the laser bending in sugar water and doesn't appear to be what we see with reality. We don't see rays of light that bend in that fashion. So we have a big problem conceptually here.
Yeah,
That
where's
doesn't.
the laser beaming at again?
I can literally show you pictures of light bending.
I
Literally
think
show.
Brenda can feel.
You can show me
Seems like
photos of
Brenda can
laser
feel this big
bending,
problem.
but the ambient illumination that we tend to be washed in that is quite gentle doesn't appear to be streamers of strings of bendy laser light at all.
Well, why don't we give
You can
Brenda a
show that.
second and let her explain how she's gonna feel this problem?
Where's the demonstration in there? Where's the video of light bending again? Where's that at? Where's the laser bending? Show that. Put that in there. Put that in the back chat.
Come on, Brenda.
Hey, if you know,
Brenda, can you do it?
everybody's seen that.
Well, no, let's see what Brenda's got. So I'm
Everybody's seen
actually
that.
curious about what Jeremy said when he said you can't prove refraction, their model of refraction. Maybe you have an example of what you mean, Jeremy. And Brenda, she knows it, so she can provide it.
Because they don't have an actual sphere, it's only numbers. But go ahead.
That was for you. That was for you. Yeah, all they did was model They took the refraction model, made it fit the globe. Of course, you've got to fit the globe, otherwise it's incorrect. And they put lasers in fish tanks, and we see the laser lower. We see, you can actually see the laser lower in the thing, and then they want to tell you, no, we're seeing it higher somehow.
You can see it. You can see it bend. You can
Lower.
see it bend.
So it looks lower.
No, you can see it bend.
Lower.
You can see it literally bend.
Down.
Why do you keep saying the same thing over? I think you're missing Jeremy's point. So we understand that you can see it bend. You see it bend lower, right?
Right. It could bend up to if you wanted. So we've all seen Rumpus's green laser in a sugar water aquarium, and the light bends.
Yeah, exactly.
Right?
So here's his laser, and we're watching it, right? And let me see if I can bend this. So the refraction is happening somewhere in here, and we see this laser bend, and it bends down, right?
Where are we seeing this at?
Well, we're just seeing a drawing right now, but this is an example of
We've
what we
seen
can
it in
see.
fish tanks. We've seen it in fish tanks with laser beams.
It's on my screen. I should be sharing it. Can you guys see it?
Yeah, we see it.
So refraction. So to begin with, refraction has nothing to do with the curvature of the Earth.
Right.
Okay, so we're talking about this laser. So you're shooting this laser through this fish tank, and it's bending down, right? It's refracting downwards, and we're seeing it bend downwards. Correct?
Refraction has to do with the supposed curvature of the Earth because we're assuming that a hump of Earth curvature is blocking what's beyond number one, and number two, that we're seeing further than the said geometric hump horizon because of the string of light refracting over it. So refraction is used to prop up the defunct globe model.
So that's wrong.
Can we please let Brandon walk?
That's wrong.
Yeah, hold on. I don't want to get into that. I know you want to get into that, but so you're shooting the laser through the fish tank. We see the laser light bend down. It refracts down. The light refracts down, right?
Refracts towards the denser medium. Yes.
And that's what we see. We see the actual laser bend down.
Yes.
Okay. So we see the light that refracts. We see it lower.
Refraction is an observed physical phenomenon that would happen on a flat or a globe Earth.
Yeah, I don't know why you keep saying that. What point do you think I'm trying to make?
She's fucking retarded, bro. I don't know if you ever listened to this bitch talk.
I know what point you're trying to make.
Well, this is what we're told.
They're going to obfuscate the shit out of you. They'll never answer.
I'll answer.
Let's say we had a little man inside the fish tank and he's watching this thing. What we're told is that this man, what he's going to see because this light is refracting downwards, and maybe you can help clear up this misconception for us, is going to see the object higher because of this.
Right.
Right? The light's refracting down. The laser light's refracting down.
It doesn't see.
We're going to see the
doesn't see the light.
source due to this refraction higher. That's what we're told, right?
Right.
Yeah, because psychologically we perceive
the whole
light as traveling in a straight line. So we assume that if we see a light, that it has traveled in a straight line. So we make the psychological assumption that the light source is higher than it is.
I don't necessarily agree with that, actually.
I don't need no psychology here. So it doesn't see the light that reaches feet, right? It's the light that reaches the eye. There are many rays like that goes to him, and one of them that bend just like this will hit his eye. Now we need to go through a lesson. How does the eye work, right?
So if we started off in a vacuum chamber and we had the laser beam shooting straight at his eyeball, then we let all the gas into the container, and now it's not a vacuum anymore, and it starts bending down, or we fill the tank up with some kind of heavy gas at the bottom, whatever, and the light starts bending down. The laser beam's going to be hitting the guy above his head, or is it going to be hitting his feet?
Below his head, so it doesn't see it anymore.
Below his head, of course.
So that's why
he's going to
you have
look
to lower
down,
your height.
see the laser beam. He's going to look down, see the laser beam hitting his feet, and he's going to see it lower, right?
No,
he's not going to see it lower.
No, we're not
That's not
searching.
the
We're not searching where the beam hits. We're searching where it came from. Now he can't see it because it's a laser beam, and it dropped below his eye, and he would not see it anymore.
Right.
Yeah, he can look down and see it lower. He can look down and see it lower. It's hitting his foot.
The simplest way to explain this is that the source of the light is higher than where you're receiving it from. So when you get that information from that source, it's higher than where you're getting it from. That's it. So it has to bend down for that information to reach your eyes, and then the source is higher than what you're perceiving it as. Yes, so it appears lower when the light drops down.
So we're gonna see the light when it's at us. We're gonna see it lower.
Yeah, it sounds to me
Because it's
like
gonna be at his
exactly
feet.
what Brenda said.
Yeah.
Brenda,
Yes,
do you want to clarify?
Yes, it's exactly what I said. You can simply Google and do an image search for refraction, right? And you get the image
Okay.
of say.
I'm not sure if everybody really
Why are
understands,
you
Brenda.
talking
Can
over
you take it from the top?
Why are
Brenda, you got an
talking
echo. You have an echo going, Brenda.
Oh, yeah, sorry.
Learn how to use your
Brenda,
fucking mic before you start getting in here discussing refraction. Learn how your fucking mic works.
Wow, Jeremy's on one today. Missing that
But
second eye, huh?
Brenda, I'm sorry, I didn't. I
Yeah,
heard some acting that it was you, but I think people are a little bit confused, and maybe you should take it from the top and just explain it, the whole thing again.
I don't know if that's necessary, Branch.
No, it's not. Branch is
this
trolling.
better? Is this better? Is this better? I apologize. I didn't have my headphones on.
Yeah, I think it's better.
You do it every day.
Right. So, Jeremy, the way refraction works is that light bends when it transitions from one medium to another medium that has a different density. And then we judge, where the light source is, right, based on our assumption that light travels in a straight line. So if you're looking at a fish from the river bank, you will misjudge where the fish is because the light coming from the fish has been bent when it left the water. And
No, it's not bent. No, it's not.
Exactly
Your
what happened.
mind is bent.
Well,
Straight lines aren't bent.
This is like third grade science, so get over it.
Shut
Yeah,
up.
so prove it.
So in the case of the laser, why do we see the laser bent down? We could see the source where the laser is. I don't know, maybe we're seeing the source elevated too, but we still see the laser beam bending down. Is that because there's some secondary light coming off of the laser beam as it goes through the air, or what's your explanation for that?
In what angle this laser beam hit our eyes?
We can see the laser beam actually. We can see the laser beam actually bending down and hitting down by our feet.
When it hit the eye, what is the angle it hits the eye?
What are you talking about? What is the angle it hits the eye? The laser beam itself is not hitting the eye. It's going down here, and it's terminating at his feet.
Yeah, but we don't see it, right?
We would see that, and we do see that. Otherwise, when we look at a laser in a fish tank, we wouldn't see the laser light bend down, right?
Yeah. So put an eye in there and tell me what angle this beam hits the eye.
This guy has an eye. It's
well,
not
it
hitting his
doesn't
eye.
hit it. Imagine replace the guy with an eye.
Oh my God. Okay.
Where does light do this in reality? Why are we? I never in my life seen light go down and down and snake around or bend anywhere like that.
You've seen the gifs of the horizon moving up and down,
when you're
right?
on the freeway, when you're on the freeway,
You ever
right,
seen real life reality in front of your face outside, right?
Right. That's exactly what I'm talking about.
So Brandon,
there you go.
So Brandon, I put a
great
in chat of a green laser being bent in sugar water.
Yes, we know.
Well,
So,
this is difficult. This is difficult for them, Chike.
No, it's not difficult for us, Brenda. Don't listen to her. Don't listen to her. Don't listen to her. She's just trying to bait us.
How are you not understanding this? Do you get it?
They do.
No, they don't.
Cool picture. You got the video.
They do.
You got the video from start to finish.
See, he doesn't.
Yeah, any Glober. Any Glober who believes that.
I'm not talking about Demo.
Start to finish video, please. Fuck your picture.
What's wrong with that image?
You're a
What's wrong with the image?
What's wrong with
Okay,
your
so
live
anyway,
video?
so back on Chike,
I mean,
you got the
you
eyeball
guys
in here
could just
now.
complain that
The
that's
laser
water.
is terminating below the eyeball.
Well,
and
if it
seeing
terminates below the eyeball, it doesn't see it. Put the laser
I see it
beam
right
in
here,
his
you
eye.
dumbass. Look.
No, that's scattering from the water. You don't see the source light. Imagine there it's perfectly clear, like every other day, and the beam hits your eye. It refracts like this. Hits your eye. What happens?
Okay, so that's what I just asked. If it was some scattering from the actual beam of light as it's going through the air, and that's why you still see it bend down, or what? That was my question, remember?
Of course.
Okay, so I think that answers...
Otherwise you wouldn't see it. If it was red laser, you would see much less.
Yeah, I think we need to see that same picture with a red laser.
So I think that answers Jeremy's question on why we see it bend down in this sort of setup, Jeremy.
Can they hold on? Can they prove their claim that the mountain or the oil rig or any fucking object out in the distance is actually where it is? No, they can't, because it's not a measurement. They're just making calculations based on assumptions. So I mean, there's nowhere
calculations based on measurements.
Okay, well, let's show us a long distance experiment that has determined what's happening with the light, the refraction in between the two distances.
Well,
show us how you would do that.
There is a long distance experiment going on in LIGO, and they don't have no refraction because they don't have air in there.
I know, we're talking through the atmosphere though, Chike.
He doesn't even know what the argument is.
Jeremy, it's very hard to understand what's your argument.
There's no refraction in LIGO.
Video from start to finish of something.
Right. There's no refraction in LIGO. Go out and there is a refraction.
So I put a picture from yesterday's topic. I put a picture in where Mount Caillou or whatever it is appears to be higher than it actually is due to refraction of the atmosphere and bending the image from the mountain over the curve.
We know the model.
Well, that's 263 kilometers. You asked for long distance. There it is.
How did you determine that what you're seeing is a projection? Is this one, this dotted line mountain, and not you just seeing the fucking object on a flat Earth?
In this case, well, we already know that the Earth is curved.
Yeah. Step one, assume the Earth's a ball.
No, well, that's what's called a hypothesis. And a hypothesis is an assumption. There's nothing wrong with making a hypothesis.
So you said that the model of refraction is well known and has been proven experimentally. I asked for over a long distance, say, I don't know, 10 miles even. What is your experimental evidence for what happens to light over 10 miles? How did you build this model of refraction through the atmosphere, long distances?
Didn't Gleamer Cleary provide scientific evidence used by the military long distance? Didn't they just provide it last week?
Well, refraction does occur,
Is
but
that
we need to see
that's your evidence? Is that what I asked for? That's your evidence of the model?
Isn't that long distance modeling of refraction used experimentally in the real world? Isn't that what they presented?
I don't know. Brenda said that it had been proven, and she could show it to us. So I'm asking her to show it.
Oh, no, that's my mistake. Okay, yeah.
So refraction is an observed phenomenon that would be true on flat or the globe Earth, right? Because it is simply a consequence of light leaving one medium and entering another denser medium. And so therefore it has nothing to do with distance. It has to do with the waves.
But Brenda,
she doesn't understand the question, does she?
Hold on a second, though. Brenda, people keep saying about it would happen on a flat Earth too, but the reason why it actually curves the way it does is because part of the reason that the Earth does play a role in it is the Earth itself is heating the air, and the differential of heat in the air causes an enormous amount of influence on how much the air bends.
Right.
So the air itself is being heated, if you want, uniformly to the shape that it's residing on, which is the ball.
I'm talking only of the physical phenomenon of refraction, which occurs simply due to the light waves entering leaving one medium and entering another.
How many times are you going to fucking say this?
Well, until you get it, that it has nothing to do with the curvature of the Earth.
You have a model of refraction. You have a model of refraction that has certain assumptions on what happens to the light between object A and B. How have you proven that model correct?
It has no assumptions. It's an observation.
I think we have here a fallacy of composition. We need to
we don't.
Over a flat surface, and at best, getting an image that is there over the flat surface magnified, versus the fallacy of composition where you try to connect this to the sugar water laser that is curving up and over sugar water. That would make light a string, bringing the image up over the curve, as opposed to it just being there for a flat plane.
Do you see where our atmosphere has sugar water at?
You wear glasses? Does anybody in here wear glasses?
So I guess the conclusion is that you don't have any experimental evidence to back up your model of refraction.
No, it's entirely backed up with experimental evidence.
Then
Refraction.
Show it to me.
It's like I can give you pages of it. Just go to
Brenda,
I think the only thing is, Brenda, we have
maybe you should show us
two
those
things
pages,
that are
Brenda.
possibilities here.
Get the pages,
Over
Brenda.
the flat plane, we could just see the image blown up and magnified, or we could see the string of light, like the laser and sugar water, be brought up over the curve. But for that second one, Brenda, we need to see a split image. The original image over the globe and the lifted up string image above the original image. Otherwise,
what you're talking about. It's completely uninformed. So anybody in here wearing glasses, the reason that you can see clearly is because of refraction. And if you were transported from a flat Earth to a globe Earth, your glasses, the lenses, would work exactly the same. It has nothing to do with the globe.
Glasses are only formulated with lenses.
That's refraction.
Brenda, glasses are only formulated with lenses.
Lenses refract.
No one is disputing that fucking refraction happens.
You are disputing it. You are disputing it.
No, we're not.
So the atmosphere can act like a lens?
Changes in density of the medium cause light to refract. And
Well, that's the first time you've said that. You keep
oh, I've
saying
said it a
changes
dozen times already.
You've
But
said
Brent-
changes in medium. You keep acting like we're going from two different mediums, and we're not. We're only talking about air. We're not talking about air to water or air to glass.
We're talking about the density of the medium. Try to listen again.
It can still be the same material, but a different density value.
Yes, but they don't. So they don't understand the refraction at all. Not even a
But
little.
with greater and greater distance, the air gets thicker and thicker. I mean, this is philosophically quite problematic, this way that we're looking at light. And I can take, glasses in front of my eyes and see the marked boundary between what the glass is presenting versus the air around it. I have a duplicated image to go off of. I don't have a duplicated image of string a light over this ball to go with your conception at all.
Yeah, that's the problem. You've got this model. You've got this model of how the light is bending over this curve. It's in this image that you showed me. You say that this is happening. What?
Yes.
What?
Yes, that's what happened.
And then when I asked you what supports that this is happening, you said, well, first we assume the Earth's a ball.
What supports what this is happening would be the laws of refraction.
Oh, fuck me. Never mind. Forget it, Brenda. I'm good.
It's just a bit of fallacy of composition, Brenda, because part of it could be true with that laser and sugar water, but I'd need prima facie evidence that it's the case with a duplicated image. Otherwise, I can't quite trust
What is
Well, the black
the fallacy
is a good
composition?
example of that.
What's that, Howard?
I said the black swan comparison, where it shows the black swan next to the regular, what they see everyday image. That's a good example of refraction versus minimal refraction.
Which one is the minimal and which one is the real? How did you determine which one is which? That's the question.
I would say that the minimal refraction would be the one with the more stable, more representative of what reality is. The straight booms, the buildings look proportional.
Yeah.
The image with all the distortion and the bent crane boom or plane boom, whatever it is, the buildings are stretched out and everything. That would
So when
be
did you
severe
take
refraction.
the atmosphere out to look at it with no atmosphere through a vacuum to observe what its natural position is out without a medium?
Yeah, that's impossible.
Exactly. That's what I'm asking you guys for, is how you determine what the correct baseline for how something at a distance should look. Let's take the black swan. How do you know what the baseline is?
I know what the baseline is not. We can get to a point in which what we see is reflective of reality, and we can obviously say when something is not similar to what reality is. So, for example, in that black swan picture, when we look at the oil rigs, they're fucked up. We know right off the bat that we're not seeing what reality would dictate on a clearer day or at optimal parameters.
The only thing is, it's unscientific when you don't have a baseline to have comparison off of. At the very least, the flatties are trying to have a geometric horizon baseline mathematically anyway for comparison and some level of analysis.
Yeah.
The Globers don't appear to have that. They have any amount of refraction, I guess, necessary to curve light like a string over the ball. That's not very.
Yeah. Have you read the Green Flashes website?
No.
No. Then you would know that what you said is a lie.
In what way?
Because he measures refraction.
We're not saying that refraction doesn't occur. We're challenging whether refraction is bending light like a string over the ball.
Yeah. He measures that.
Really? Well, that's what I've been asking you for, was what your evidence of this is. So let's see it.
Andrew Thomas Young, right? He starts off with a flat environment, measures the amounts of refraction, and then switches to a model of the Earth where we have a curved environment, right? So he starts with a flat surface, measuring refraction over a flat surface.
What was the flat surface?
I don't remember exactly what his
Oh,
experiment
come
setup
on.
was.
You must
I don't remember exactly.
Or go get the video. Go get
Where's
the material.
Travis when you need him?
No, I'm not
Go
going to
over
step
it.
and fetch. I'm not going to step and fetch for you. There's the website.
Go and
Everybody
bring
knows the
material.
website.
Don't bring shit to the table then. Go and bring the material. Bring the material that's convinced you that refraction is causing the black swan to be like 10 miles refraction. Go bring it.
Well, refraction does occur, Brenda, like you say, but I think we need to challenge whether this is really what we're seeing, whether it's a curved line of light string going over a ball, or if it's over a flat plane and at best magnified, diminished, enlarged, or
Refraction is not a banana. Refraction is not a banana. Light can widen out like a pair of binoculars. It can widen out, it can go, and it can focus back. It's like a fucking pyramid, forward, backward. It's not making bananas. It's not making fucking snake patterns. Get real. Show us this shit.
The thing is, I'm in a movie theater and I can see the projection getting closer to the screen and magnifying the image with refraction through the lens based on
You're looking at the medium. Shut up.
but
You're not looking
still
at light.
back to that projector. I'm not absurd. Like
You're
the
looking
light
at the
curves
mediums.
over the hump of the
Mediums
movie
that are
theater. I
going-
mean, that's just
Hold
know absurd. I
You're
mean,
looking at the air holding the light.
I don't know.
You're seeing the air hold the light, the medium. Just like water, it acts different in water, it acts different in light, it acts different with sugar, it acts different with salt, it acts different with crystal, it acts different with different stuff, it acts different with a pyramid, it acts different with a sphere. The medium controls what you're seeing.
Absolutely.
The light's not doing it.
Every medium has an index of refraction. It's unique to the medium itself.
Yeah, well, quit saying
And
what light
changes
does when you're
its
explaining the
temperature.
medium. Try better.
Also, we
The
have
rail
a
gun,
difference.
The rail gun can hit a target 120 miles away at Mark 5, leaving the barrel at Mark 7.
Yep, and it goes up to 150,000 feet and it comes back down.
No refraction going on there. No
Well,
It goes up and then it comes down, Jim.
line of sight.
I want the snake laser. Where's that? The laser that goes like a snake up and down and refracts.
Yeah.
Well, the problem is
Bringing all kinds of stuff to the table.
The
Yeah, you
main
shotgun
thing-
enough and then people can't address all your points so you feel like you won. That's what happens.
The problem is we have a serious category error. The laser light in the sugar water is shaped light. Most light that comes from a point source is not shaped like that. It just disperses from the source in all directions with no real shape. So we have a bit of a category
think
error
what
here
needs to
because most of
happen-
the light that we see
Maybe
is not
what we
like
need
that
to do is
laser in
we
sugar
need to have
water.
the same water
I want the
experiment we
banana
done
lamp snake
with
light.
red laser. We should get done
So
with
that
red
shaped
laser.
light would,
That should make a
bend
huge
and, do weird things that normal point source light normally doesn't.
Yeah, I want the light that arcs over my head and keeps me dark but shines on the ceiling only and goes around me. Can I get some of that, please? Some of that banana laser light?
Yeah, you can. You can, but it will
I like
cost
some of that as well.
Well, I'll tell you, I haven't studied Andrew Thomas Young, and I doubt Brenda has read all of his stuff and studied it as much as Travis. But what Travis tells us from his study is that he assumes that it's a ball already. But Brenda, you're saying that he started off with an assumption of flat and then derived somehow his refraction analysis from
Well,
that?
what you do in all science is you reduce the number of variables to as few as possible. So if you want to study how light refracts in the Earth's atmosphere, which is curved, first you have to start with the case where it's not curved. And then you can establish from those observations, and then you can use those and build on those in order to make observations with regards to.
You have the sphere you look at.
Hold on. Describe to me how you would do that. So here I am. I want to study refraction. What am I starting with? Describe this to me.
I think you'd start with Snell's law, wouldn't you? And you'd start with Snell.
No.
I'm going to test it out via experiment, Brenda. What am I going to do?
You would study the incidence and reflection and refraction of light as it enters and leaves different mediums.
Well, Brenda, I think what he's asking is this: if he wanted to do an
Well,
experiment,
maybe we should go over
how
how
would he go about
refraction would
doing
work over a flat plane. Over a flat plane, if
Yeah.
refraction is making the ceiling and the floor ramp together and smush everything into an unresolvable horizon line, refraction would make things pop out of this horizon line occasionally or smush into it sooner. So I think we need to work with a different refraction model where it's not a string going over a globe, but something popping out of the diffraction limited zone where the ceiling and the floor are effectively merging together over a flat
I mean,
plane.
an obvious proof of refraction.
We need
If
a
you-
different
if you-
interpretation of refraction.
If you really want to
over
see, if you
something
really
Hold on,
want to do
Lemon.
an experiment, Brandon, then find something very long distance, and
also at the boundary
Hold on,
between
Lemon.
media.
Can you not hear Branch,
Oh.
Lemon?
Oh God.
You got to
and
mute
Brandon
him.
basically, make a note, Brandon, of where it's
Sorry.
at
That's all right.
on a cold day, and then go back on a very warm day, and go back on, a mediocre day, and just see if the heights of the things in the distance change. 'Cause
Well,
if
we know they do
change.
change. We know they change, right? What's the baseline though, Branch?
I just thought you wanted to see refraction.
Oh no, I get you. Yeah, no, that would be a good way to go about observing it. I want to know how we determine what the baseline is for what we're supposed to see, especially at long
Don't
distances.
need no baseline. Don't need no baseline.
You don't need a baseline.
Well, Brandon, what do you mean by that?
Do you have a
I'm actually
baseline?
confused, Brandon. What do you mean by a baseline?
Here's what I mean. Here,
Rumpus,
if I go out,
you're really quiet, Rumpus.
is somebody's mic open or something?
Rumpus, but he's very, very low.
Well, dude,
Oh.
I might be able to help him out.
Yeah,
man.
My microphone's very low, is it?
Still very low, yeah.
Yeah.
No, it's not.
You're very low.
We're saying that flat gang versus
Yeah,
non-flat
you're not
gang battle,
yourself.
bro.
Sounds much
You can
better
help out
though,
Brandon,
Rumpus.
I will.
Here's what I'm saying. So if you can see my screen, so if I go out there on a cold day and I see the mountains are up here, and I go out there on a warm day and I see that the mountains are down here, just for example, how do I know where the mountains actually should be?
They don't need to be anywhere. You do measurements at different days, and according to the difference, you figure out where they would be if there was no refraction at all.
How do you do that?
Well,
Go
you could
out
use the.
different days, see where you see them, see the
Your baseline's going to be geometry, and then refraction's going to fuck it up from there. How about that?
Well,
That's a good answer, but then that would go back to BioDual. My position, as it's always been, is that you can't determine the shape of the Earth with long-range optics because you don't have a baseline. You have to assume a baseline and then build your model off that, which is what it sounded like you just said.
No, so that'll be your baseline. That'll be your baseline. So whenever anyone talks about the geometric horizon, blah blah blah, that's fine as a baseline. We just happen to have an atmosphere that'll fuck it up from there. And one of the ways that you can come close with optically, one of the ways you can come close is just going out at a high altitude where the extreme refraction won't exist, and the amount of refraction will be minimal, and it will decrease as you raise in altitude. So you ever come closer to the accuracy and reliability of your geometric measurement as you raise in altitude.
So I do have to assume a shape of the Earth to start off with. So this isn't a good way to determine the shape of the Earth.
It's a hypothesis. It's a hypothesis. My hypothesis is that the Earth curves. I'm going to get to a high altitude so that I know refraction is minimal and won't fuck up my measurements. And then I would take my measurement. You can assume that it's flat. Your hypothesis is the Earth is flat. Come with me side by side. We'll take some measurements. And then we'll go to a different altitude and we'll take some more measurements. And then we're going to see what our measurements, what shape it closely resembles or matches perfectly.
I mean, I would actually say, Brandon, if you actually want to get a real understanding of where that thing should be from where you're at, right? Visit it several different days, right? And then take averages. Because the problem is this, is that refraction is very dependent on temperature. And it's very hard to get a temperature from wherever the root of the object is, all the way down to you to be a uniform temperature. It's super hard. So I just said this. You know what? Take an average of, let's say, 50 views, right? And then you can essentially, using that, figure out the index of refraction that you're seeing, and then a count of an index of refraction of 0, and that should point to exactly where the object actually is.
So it's not technically due to temperature, it's due to density. But in the air, cold air is denser than hot air, so there is a relationship there.
It's a direct relationship.
Well, I think we can start from a different starting point, that the Earth is flat and that the diffraction limit is making the ceiling and the floor merge into an unresolvable zone in the middle called the horizon. And that refraction at best makes things pop out of this diffraction limited zone at best, as opposed to the string of light curving over the ball. So I think with this new starting point, we could get some new theories and possibly some new calculations.
No, Lemon.
Right.
you
I
know, things
mean,
work
essentially,
even if they are very far from.
I did,
from Earth.
Brandon. I did say it very, I basically just said, figure out the inner cell refraction. There's formulas you can use, and I can provide them to you if you want. I'm sure Brandon's probably worse than I am.
Could somebody
actually gives a fuck a lot more. But I'm sorry, Brenda. What did you say?
Rumpus is asking.
Did you say something, Brenda?
No, I didn't say anything. Rumpus is muted again?
Oh,
he's asking to be unmuted.
All right, he's unmuted.
Oh.
No, somebody else is muting him.
Hold on, guys. I got it.
Yeah, someone keeps muting me.
That was me, Rumpus. I'm very sorry.
You had a hot mic.
Yeah, for about 2 seconds, yes.
Well, you was very high on the wanker scale, so I muted you.
You're a wanker. Yeah, you're a wanker, so we established that.
That was hilarious, though.
So I've just put a demo video for you, Brandon. You were asking what you could do to determine how refraction works. I just put a video in there, which is just a rectangular block, and someone's got just put a little a line through a grating just to shine a line like a laser, but it's actually just normal light. And then that you can just rotate the block and you can see what Snell's law is, which is what Brenda was talking about. So
I appreciate that. Yes, maybe some people are unfamiliar with that. I am familiar with Snell's law, believe it or not. I understand the index of refraction and that different mediums and
understand the
densities,
basics then.
light changes direction.
The angle of incidence equal to the angle of refraction. The Snell's law determines what the difference between the angle of incidence and angle of refraction is. Well, right. So you were asking if you wanted a demo refraction. That's it. That's all that's needed. And if you then know that's based on density, and you know that the density in the air is greater at the bottom than is the top, then you know that it's going to curve down. And so there you've got the basic rules sorted immediately as to what light's going to do. It's going to follow the Earth. And you were asking what the base position is. Well, given the fact that we know what the design of an oil rig is from its design, from the drawings, we know what it should look like. And so if it doesn't look like that, we know there's something wrong. Normally, refraction preserves the aspect ratio, and it just moves things up and down.
You're shotgunning.
Sorry?
Ooh.
So I find it interesting that you're going with bendy cranes, same as BioDual did. That's interesting because we know that there is air turbulence.
Where did I mention bendy cranes? I didn't.
Well, when did you mention bendy cranes? That's essentially the argument you're making, right? We know what an oil rig looks like. We know what it should look like.
I mentioned bendy
okay,
cranes.
Rumpus, can you stop?
I paraphrased your argument. That's what you guys usually mention. I paraphrased. Is that okay?
Stop talking about bendy cranes, Rumpus.
Bendy cranes.
Stop
Why
it.
are you saying I
Stop
did?
talking about...
Shut up, you twat. Why are you interrupting my point? Why are you claiming I mentioned bendy cranes? I didn't.
Well, did you hear me? I said twice. I paraphrased your argument, which was that you said we know how an oil rig is built, right? What does that mean?
That means we know what it should look like.
Okay, and what's wrong with how it looks like in the Black Swan?
Sorry, could you repeat that?
What is wrong with how it looks in the Black Swan?
It does not look like the design we know the oil rig
What
has.
do you mean it doesn't look like the design?
We have pictures of it from very close to, so we know what it should look like.
What is off about it? It looks like it to me.
That's not a real thing.
What? Somebody tell me. What's off about it?
Are you serious?
Yeah, tell me what is wrong with
serious?
it.
You're just joking here.
No, tell me what's wrong with it.
I think you
my
are
God.
joking, but I know we're going to entertain you.
Right here, I'll give you two
They're
things about it.
serious.
One, the cranes, the whatever they're called, the flame pylons. They are incredibly bendy. They do not agree with
Thank
the
you
drawings.
very
They do
much.
not agree.
My
they
point
do
is
not
made.
agree with
Thank
the
you
pictures.
very much,
Now, and
Rumpus.
similarly, also, there's another point I'm trying to make. If you look at the aspect ratio of where the platforms are, and you compare that against a picture that's close to all the design. Let me finish without being interrupted. Nearly there. It's compressed and stretched in different places. It does not look like it's designed. It does not look like the pictures of it close to. How can you dispute that?
I'd like you to acknowledge that one of your arguments was that the crane is
fact
bent.
that your geometric horizon is well and truly fucked.
I didn't make an argument before. You asking me. Ask me a new question, so I've given you a new
Yes,
answer.
you did. No,
It
Rumpus.
does not look like it's designed.
I
does
heard
it?
you, Rumpus.
So why are you questioning that, Brand? I mean, it's an unbelievable question.
You're trying to obfuscate. I don't know why.
No,
why,
I'm not
why
at
are you getting
all.
hung up on this? Just because I paraphrased your argument.
Well, you because you ascribed to me something I hadn't said, and now you're asking an incredibly stupid
And then
question
I
as
asked you to
why
expand on
we
it.
think that Black
And you
Swan
did.
doesn't look right, and it's because it's compressed, it's stretched, and it's also got the bendy bits in it.
So
Well, how can you dispute this? How can you seriously
it doesn't
dispute
look
this?
perfect.
You must be joking.
I'm not saying it looks perfect. I'm not saying it looks perfect in any of the pictures.
It does not look like it's designed. It does not look like the pictures of it close
It
to.
never
does it?
will from 10 miles away.
Well, it does in the
won't
second picture
but
I
its
just provided.
aspect ratio would be preserved, and in many pictures, like we've got someone just posted, the aspect ratio is preserved most of the time you look at it, and that reflects the design. It reflects pictures of it when you're close to. How can you dispute that the Black Swan is the peculiar one? I mean, you can't be this stupid. You can't be. You must be joking.
I'm done. I'm done.
No,
Yeah,
you
I bet
must
you
be
are.
joking.
You were backed into a corner because we thought you were joking, but the fact
No,
that you were
no, no.
serious.
I'll tell you something. He's right, because in this picture right here, is this from 10 miles away?
Each are from the same beach, from beach to rigs. Each
Okay.
picture.
I will
There's
not
my-
deny that this is a
there's
lot
my
cleaner
rendition
picture.
of the Black Swan. There you go. In CBR1's picture of the Black Swan. There you go. Clearly there. No bendy crane.
So the real problem is that the globe Earth model predicts the image of the Black Swan. It doesn't refute the globe Earth. It confirms it.
Flat Earth, where do you got the globe at?
No, I beg to differ because Rumpus has done the calculation with Ranty on this show, and it actually turned out in favor of the flat Earth more than the globe.
No,
I
it did.
doubt it. You're not capable of reading a
Rumpus,
picture.
type in the chat. He will confirm.
So the prediction of the globe Earth is confirmed by the Black Swan. It is not disconfirmed.
Yeah, all I remember, right, Brenda, because I was there, on the stream, is that Rumpus and Ranty both went through both photos and calculated the angular size versus the Earth curve.
I'm talking about angular size.
No, hang on. Well, that's the flat Earth model.
No, I'm not talking about angular size.
No, that's the flat
talking
Earth model.
No, I'm talking about the position of
No, that's the
apparent
flat
horizon.
Earth model.
I'm talking
They
about
were comparing models and maths.
No, I'm not talking about this other thing that you're thinking of. I'm talking about the fact that the apparent horizon is behind the two oil rigs. That is a prediction of the globe model.
It's not
you sure?
behind.
Are you sure it is?
The apparent
Brenda?
horizon is. The apparent
Who predicts that? Who predicts
Well,
that?
It depends what you call apparent horizon.
Well, yeah.
Who
I
predicts that?
declare
Sorry.
Brenda the queen of flat Earth.
Who predicts that? Sorry, Brenda. Andrew.
The globe
does he?
model does. The globe model does.
The globe model predicts that massive
That
refractive effect,
under-
which changes your horizon from 3
Right.
3
Under-
miles to about 10, 15.
So the globe model predicts that under conditions of extreme refraction, right, it is possible for the apparent horizon to be behind objects that would normally be obscured by the geometric horizon.
Yeah, the flat Earth model predicts that too. It's
No,
nothing
it doesn't.
special.
No, it
does.
doesn't.
Yeah, it does.
You can't have a horizon at all on a flat Earth.
Yeah, you can. You're just in
No,
denial.
you don't even have one with your
A
geometric
horizon,
It's
a
not even
horizon
there.
is created by the sheer fact of the Earth being a sphere. You can't have a
No, it's
horizon
not.
at all on a flat Earth.
Nonsense. Nonsense.
Yes, you can't
Nonsense.
have a
Absolute.
horizon.
Professors of
So a limitation
mathematics have said
is-
that
Why not?
your actual horizon is made by perspective.
So you
Nobody
can't have
says it.
a horizon on a flat Earth.
Yes, you can.
Why not?
Because a horizon is created by the Earth getting in its own way.
No, it's not.
Obstructing itself.
Earth getting in its own
No.
way.
Horizon. That's what makes a horizon.
Get out the way! No, you move. You move.
Yes.
You move.
No, it's not.
And the bits of the sphere that are over the horizon are obstructed by the Earth itself. That's what a horizon is.
Are you really still trying to sell that?
That's actually not a bad point because you guys bring up these perspective ladders all the time, and you always bring up the railroad tracks. Well, on a flat plane, even let's say fucking Kansas, where there's like generally no elevation change, even on a flat plane there, you should be able to get a telescope and bring back those railroad tracks, no matter what the distance is, because the angle from railroad tracks 100 miles away to you is still a positive angle. So it's a matter of magnification. You should, in theory, always be able to bring it back. You just can't.
Can your eye operate forever?
That's why I just said telescope, didn't I?
Yeah, but a telescope, okay, can a telescope magnify forever?
It potentially could. It would just be hindered by the environment.
Oh, okay, so the atmosphere is a thing.
Right. So what we would expect to see
And so
is not a
there
crisp
could be
horizon.
dust, there could
What we
be
would expect
scattering
to
of the
see,
light.
what we would expect to see is objects fading as distance increases because
No,
the
we wouldn't.
atmosphere gets thicker and thicker between you and that object, so it would fade. You would never have a crisp horizon.
Bullshit.
Well, no horizon at all, but what we have today is a crisp horizon.
No, we don't.
I know, that's a good rebuttal. Fantastic.
It is because we've got plenty of observations where there's no crisp horizon.
Right. There are plenty of observations. I'm not disputing that. What I'm saying is that we have a horizon. In any observation you make, there is a horizon. The dispute is where this apparent horizon is. On a flat Earth, we wouldn't even have the word horizon. We would just say, yeah, that object is like half faded due to the atmosphere because it's 50 miles away. That's what we would say.
yeah.
We wouldn't even say horizon.
No,
So
we would have
the Earth isn't. Well, first of all, the Earth is not perfectly flat. We are looking through an atmosphere. There is refraction. Maybe in this perfect world inside of a vacuum with a perfectly flat, level plane underneath us, maybe what you're saying is true. But
so if the Earth,
not in reality, Biodual.
If the Earth was an infinitely flat, perfectly flat plane with atmosphere, things would simply disappear into the distance into a gray kind of mist.
No, they wouldn't.
It would just fade out. It would just fade
No.
out. And then, furthermore, what we experience now is, yes, we are looking
That
through
would
the
kind of
atmosphere,
depend
but
on how big
things
the
are
object
obviously
is. You know, like
obstructed.
mountains in the distance that look a
that's
little bit
perfect time to
duller
interrupt.
than the things that are closer to you. Yeah, that
You
effect
had
is
to
obviously
talk
going
over
to
him.
increase. If the thing in the distance is larger, but because things are small and
you couldn't wait,
tend to reduce in angular size before that, then yeah. But
You're
stop
right,
making
angular
claims.
size. That's why I brought up the telescope, because what'll happen is if you have a powerful enough telescope, what's going to happen is that the resolution that telescope provides would be greater than the atmosphere would fade objects out. So you would be able to see this fading effect with the telescope, of course.
No, he wouldn't.
Right. And so
Another great rebuttal by Brandon. You're doing great.
If there were
Well,
no,
you're just
if there
making
were no
proclamations. You're just making proclamations that this is how it would be. This is what we would expect. This is how it would be.
Articulate the issue then. Articulate exactly where I'm wrong.
You're making shit up.
Articulate exactly where I'm wrong.
You're making shit up and claiming that it's real.
Yeah.
Right. Articulate the problem.
Well,
I rest my case.
making,
Thank you.
So
that is the problem.
You're giving us an example, right? And you're saying what would happen in the example, and you're just saying that. That's the problem.
Right, and you have a problem. Articulate the problem.
There's no demonstration.
Again,
say
you already have a
anything I
problem.
want.
Articulate the problem. You
You're
didn't say
making-
I need a demonstration before I subscribe to this
make-
or something
you're-
like that. You
you're
said I
making-
am wrong.
You're
Articulate
describing
where I'm wrong.
You're describing a scenario, and you're describing to us what you are saying would happen in that scenario without providing any evidence whatsoever.
That would be a proper response. But saying I am wrong, I need you to articulate
You're
where I'm
making
wrong.
shit up. That's what the
articulate it.
problem is. You're
I'll
making
articulate
shit
it.
up.
I'll
What do you
articulate
mean?
it.
We
I'll
have
say,
seen.
can I answer, please? All right.
You going to answer?
Brandon, bio. You don't have an infinity positive angle. That's the problem on your fucking assertion.
Okay, let's do it right now then. For a 6-foot observer with an object, hold on, an object on the ground. Let's even talk the ground, the most extreme on a flat plane.
Listen.
An object,
Let me explain. You asked
let's
to
say
explain to you,
2,000
right?
miles away. What is the angle of that?
Once the you know how the ground rises to your eye level. Once it reaches your eye level, that's no longer a positive angle.
Ground
From that
never
point on,
rises to eye
don't interrupt me. I know you want to interrupt this, but that's where your positive angle dies. There's no more positive angle.
I'm going to do the
From
math
that point on.
right now. I'm so glad that you articulated that specific point because I love math, because math doesn't give a fuck about bias.
Oh, well, that would be nice if you actually provided some evidence to back up what you're saying. Because so far,
I'll
you're
provide
just making
evidence for that specific
proclamations
claim.
and then saying, rebut me. That's all
Look,
you're doing.
We have.
Yeah, I will say,
We
Brandon,
have-
I said that earlier. I made a
Well,
claim
I'm
earlier
not
that I haven't
talking-
backed up.
The thing is,
And
what
if you
if-
can look in the general chat and play the video, you won't get a strike for this one. But play the
Yeah.
video at the timestamp given. And it's a professor of mathematics talking about an infinite plane and creating a horizon. There would be an horizon created by your eyesight.
Well, I'm sure it will debunk.
It's
you,
really
but-
simple. They just don't
Hey,
get it.
it's silent.
So,
Silent.
Chuck
It's
and
silent.
Brenda,
I
you full of shit.
What do you want? What do you want? What do you
Times
want?
I saw.
Yeah, the thing is, on an infinite plane, things would not disappear
Listen
from the
now,
bottom
you-
up. They would
No,
disappear.
he's just going to
evenly.
repeat the same thing, of course.
They would. Why would that make? Why does that make sense?
Because you've got overlapping. You've got many other effects happening.
Yeah, we have horizon, crisp clear horizons with crisp clear objects.
What would you
Bio,
know,
where's the
Chike?
calculation, bio?
What would you
Where-
know, Chike? 2 minutes ago,
Did
you
I
said that the
finish
vision
fucking
couldn't.
talking, Glenn?
I know, but you're making it up.
I'm not. No bullshit.
Is there waves?
Hardly any.
The side of a boat.
Well, I'll let this play without sound, guys, and get back to the conversation. I'll put the link in the chat if you guys want to check it out.
The wave
not at all.
is hitting the boat. It's going to cover 1 meter at the bottom, whether you like it or not. You
Fucking
can't see
20
over it because that's the
20
ship.
meter
For an
ship.
instant. Just for an instant. It's not going to obscure it forever.
You are aware that when things travel away in your distance, they travel up in your apparent field of vision.
They don't.
Sure, the wave
They
will
do.
not block them, would
They
it?
do.
Huh?
No,
They do. If you had
Yeah,
two
if
1
the
meter
wave-
cubes,
how can 2
listen,
meter
listen,
wave cover
listen.
2
It's an
20
easy
meter
explanation.
ship?
You've got
So
two
a
1 meter
ship
cubes.
that is moving up in my field of view.
Chike, I'm trying to explain it to you, but you're just not interested, obviously. If you've got two 1 meter cubes, yeah, one 1 meter in front of you, one 2 meters in front of you, you can probably see the bottom of the second meter one because you're 2 meters. Yeah.
Mm-hmm.
Now you push them off to the horizon. What happens? Yeah, is that front one and the back one actually start to align. So you push them out to a mile.
Yeah, but you
and that front
conveniently-
one will
you
cover half of that
conveniently-
block,
you
which is
conveniently-
amazing.
You conveniently chose 2 1 meter cube, but I chose a ship.
Oh, God's sake. So perspective
Do
works
you know
different on a
waves
cube to a
high as
ship.
a ship?
We now have ship perspective and cube perspective, yeah? What the fuck are
No,
you
you
on
are
about?
above the waves.
You
And
are
the
above the
ship
cube.
is big, bigger than the waves. They
cube
will
is big.
never cover it. Never. Cube.
Ever.
It will.
Yeah, a 1 meter
You're
cube will never obstruct more than 1 meter, and that's right at the object.
nonsense
Yeah,
because
Gleam doesn't understand, simple
what?
ideas.
When
like
2 minutes ago,
You don't
right,
understand it.
Brenda, you were saying that the eye cannot make an horizon, and I've just cited a professor of mathematics that says you're talking shit, and now you're telling me something about what the who are you? I knew enough to cite you wrong, Brenda. Do you
Well, you
understand
haven't
that?
explained it. You haven't explained it. You just.
I'm trying to explain it. I've just said, do
Go
we
ahead,
agree
explain it.
though? Yeah, do we agree that if we push those two cubes that are equally 1 distant apart, 1 meter distant apart, but they're still only just 1 meter cubes, do we agree that the front one will start to overlap more and more of the background one? Yes or no?
An object that is.
It's a
in
yes or no
field-
answer, Brenda. What the fuck are you babbling about? Come on. Yes or no? Does it overlap it more or not?
An object that is in your field of view, right, will never appear higher, no matter how far away it is in relation to other.
I didn't ask that question. I did not ask
You
that
understand
question.
that.
You're obfuscating. You're obfuscating. I did not ask that question.
Yeah, a 1 meter block will hide a 1 meter block. So what?
Yeah.
I mean,
But it didn't
But-
when
but
it was nearer, didn't it? Didn't it? So
No,
there's a
it will
difference in
never get-
distance,
it doesn't
isn't there?
get taller.
No,
It doesn't
Gleam.
get taller, Gleam. It
No,
doesn't.
Gleam.
get
it stays
taller.
all at the same altitude.
Gleam.
But why
Gleam.
does the whole thing change with distance?
Gleam, you're talking shit because I posted a video. Calm day, calm water.
Because I posted a video.
Half a ship is missing.
Yeah.
Yeah.
And
What's obscuring the ship? There's no waves.
Who cares? It
so
has to be
sinking-
Earth curvature in your model. Sorry, Gleam.
Oh.
Who cares?
Yeah,
It
so
has to be
sink-
physical
Where's
Earth
the other
curvature.
half?
Yeah,
of the ship?
Bobby Shafto,
Yeah.
did he do the vertical temperature measurement at the ship and at the observer and all the way
Where
through?
is the ship, Gleam?
I'm telling you now. I'm asking you for the information. You're
Why do
citing
you ask
Bobby,
that for the
and I've
relevant-
already
what-
gone toe
what
to
is
toe with
it
Bobby
relevant for?
because there's this effect, right?
What effect?
Called sinking. Do you deny that as well? Does that not exist? Because that's on Andrew
what
Thomas
is
Young's
sinking?
website.
Actually,
What
think.
is
They
sinking?
get smaller. They get smaller, Gleam. They don't sink.
What
Is
does
that
it say
not
in your
sinking?
video, Gleam? Can you describe what they're saying in the mathematician's
Yeah, what he-
video?
Yeah, what he basically says is that it resolves into an arc. Yeah, there's a certain equation that he rides up for, which is the equation for perspective gradient going into the distance. What we were talking about yesterday, Brendan.
What?
You know, where you said Lee, see this, and blah blah blah.
So there's a screenshot. There's a screenshot.
But
from
play it.
Bobby's-
I'd play it seriously, if everyone can hear it. He talks a solid game. He's a
I don't think you
teacher.
guys
He's
can
a
hear
professor.
it. Can you hear it?
No,
I
sorry,
can't
I'm
hear
not talking over it. Shh.
No sound.
Yeah, for some reason the sound, because of how I have my sound set up for OBS, it doesn't play the sound through the thing. Somebody else can play it though.
Switch on the closed captions, or yeah, if you want me to, I will.
Yeah, you can go ahead and play it, and then we can understand.
Nothing that this professor says is going to explain why the.
Oh, have
that
you listened to it?
container ship-
You already know what he says, Brenda?
Nothing
So-
on it is going to explain.
Do
where
you
the
do
rest
you
of
know
the
what
ship
this
is.
professor already says, Brenda?
I know how the world works, and
moving
so
the
I
goalposts.
No,
know.
you don't, because this professor is telling you something that you didn't know. You just said that your vision cannot create that horizon. He's talking about an infinite plane here, and he says what you'll see is a horizon.
See, Brandon, that's what he's so
Hey, can you hear it?
right?
Wait,
He
shush
hasn't
now.
hear-
On a
Can you hear
large
that?
infinite plane.
Yeah, let's listen.
There was no
Click on my
trees or
live.
houses or anything. We were just on a flat infinite plane, and the only thing that was on this plane was
Is it working?
Press
an
play
X
again.
and a Y axis.
Yeah, it's working.
And maybe these coordinate lines equally spaced.
So just to go back.
So suppose that we were on a large infinite plane. There was no trees or houses or anything. We were just on a flat infinite plane. And the only thing that was on this plane was an X and a Y axis. And maybe these coordinate lines equally spaced. And suppose we could press a button, and then suddenly this graph would be illuminated. So suddenly we press the button, and there in front of us we would see y equals x squared. Okay, this is a thought experiment. Okay, we're on this infinite plane. There's nothing else around us except for us, and we just press this button, and now y equals x squared appears.
I cannot.
What would it look like? If we actually stepped back and looked at it, what would we see?
Nobody can.
We wouldn't see this. We would see something else.
Brandon
And
fixed it or something.
Hello,
this is the kind of picture that the Renaissance artists were
Hi,
interested
Jen.
in.
How are you?
No, we can hear it, guys. Most of us are listening to
What we
it.
would see. There'd be the horizon.
Oh, really? Okay.
And
Yeah.
here would be the
Join
x-axis.
Glem's chat.
And here would be the y-axis. And here would be x equals 1, and x equals minus 1, and x equals 2, and minus 2. And then there would be these lines that would all go towards this point.
Now,
of
would that
infinity,
be a
because they're all
local
parallel.
horizon? How far would
Like
that,
railway tracks,
where would
they
that
would all
horizon be?
converge here.
Why are you interrupting?
And
Well,
the
on an
line
infinite plane, it's got to be a curvature one in
where
your world,
y
isn't it?
equals 1,
In Brenda's world.
the
Surf
line where
curve.
y equals 2, the line where
Sorry
y
to
equals 3.
catch
These
up,
would
but
become
you literally arguing whether
closer
we
and
should
closer
see
spaced.
a horizon on a flat
exactly
Earth.
the same way
Knowing
as
and
I
understanding
drew
that
that
all
tile
computer
floor
games
earlier.
are based on the flat Earth and there's a fucking horizon in it. People
Yeah.
understand
Now
how
what would
fucking
happen if we
perspective
press
works.
the
Apart
y
from you
equals x
idiots in
squared
here.
button?
You know,
Well,
flat Earth is
0,
accepted.
0
Thank you.
is on it, 1, 1 is on it.
I was gonna say
2,
that. Just
4
bring
is on it.
Minecraft on a flat fucking plane. You will see the horizon. Brenda,
One
Here's the
minus
spoiler
1 is on
coming
it,
up, though.
minus 2
Here's
is
the spoiler.
4 is on it. 3, 9. Where would 3, 9 be? 3, and then 9 would be up here somewhere. Minus 3, 9. But 4 is 16. 4, 16. Minus 4 is 16. The whole thing would be illuminated and would look like this. That's actually what you would see.
There we go.
If you had a camera, you had your mobile phone, and you just press the button, and there was the
And you can look this guy up. Could you see it? Could you still see it?
Yeah.
Yeah, we
Yeah,
see it.
yeah.
What,
You can
what
look
was
this
that
guy
all
up.
about?
Professor N.J. Wildberger.
What was that all about?
He's wrote many books.
Oh,
I have
Jake,
no
it's about-
idea.
it's
I
about
have no
my
perspective.
God, you guys are so stupid,
I have
man.
no idea. He just debunked you and said that on a infinite
It didn't have
plane,
anything to do with what we're talking about, Gleam.
it
You're
did.
an
You just
idiot.
don't
No, it
understand
didn't.
it.
It didn't have anything to do with what we're talking about.
So why is he
Go
talking
back
about
and listen to the
curvilinear
show.
perspective and linear perspective again?
Did it talk about
Holy
obstruction?
shit. You're dumb as hell, Gleam.
No. Brenda
You
just made
are.
the
You're
claim.
dumb as
You don't even know
hell.
what gender
It had
you are.
Look at
nothing
you
to
all
do.
spiraling.
Why don't you
This
give
is
Gleam a,
hilarious.
hey, Brenda, you could say, I don't understand. Hey,
I
Gleam.
was
don't
just
understand.
literally
No.
told, I was just literally told by you, Brenda, that you cannot have a horizon created by
Did he
perspective.
say you can?
Listen,
Glenn.
listen. The guy is a perspective mathematician.
Did he say
That's one of his
horizon?
books. Listen,
Glenn.
He didn't
this
even
talk
say
Glenn,
is
horizon.
about
wait.
perspective.
It had
And he said,
nothing
what
to
would
do
you
with
You don't want to let him
see?
get it out,
And
do
he
you,
drew
Brenda?
the horizon.
No, he
Buffoon.
didn't draw no
Let me
horizon.
say this, guys.
Oh
let
my
me
God,
say
he
this.
said
But
it.
Brenda
He
started
said
by
you
saying,
would see an horizon. Oh
Glenn,
my God.
he,
How far
Brenda,
away would that horizon be?
Brenda started by saying that
Height
I
divided by
mean,
the
he did
tangent
not-
of the angle.
Also, would
Can you guys
that
hear me?
horizon appear? Would that horizon appear between me and a
Man,
distant
you guys
building?
missed the point, man.
Oh,
Dude,
you're
you guys
spiraling.
got dog shit argument.
Spiraling.
That sucks
Well,
because
because you
you're
were
wrong.
debunked, Brenda.
Hold on,
Brenda,
guys.
Admit you're wrong,
no one
Brenda.
trusts Brenda.
Admit you're wrong. Admit you're wrong.
Brenda started by saying that he didn't understand what was happening, and then the next minute he was an expert on the fucking subject. He was telling you that that was not what he was saying on the video. Like 30 seconds before that, he said she didn't understand. And now she's saying that she does understand.
Yeah, it's
Like,
Dunning-Kruger.
This is a person that doesn't know whether he's a she or a he or a it. Don't even know where he's coming from.
let's
Don't
not
need
go
to
there,
come with
please.
it.
Let's not go there,
Don't
man.
need to come in with it. But it neither here nor there. Either way.
Yep.
So, Gleam, what does
Are you
this
going to
have
admit it? Yes or no? Are you going to admit that you were wrong?
What does it have to do with
No
the
more
horizon,
questions.
which is an obstruction due to curvature? What does what he said have?
No, you just said
anything to do
it
with
cannot create a horizon. That was your categorical wording. We can talk about
and
blockage.
he graphed a function onto the floor.
Mm-hmm.
Yeah.
Which created a horizon, didn't it, Brenda? On an infinite plane.
Talking about?
Wouldn't that horizon be an distance away?
On an infinite plane, Brenda, in his thought experiment, there was a horizon. Where did that come from?
What he didn't mention the word horizon at all.
You wasn't paying attention.
He didn't say the word.
Look
what was
in
the
the
line
general
he drew?
chat. Trust me,
What was
you
the
are
line he
drunk.
drew?
Right, here we go. It's as simple as this. I disagree with his assertion because he also says that particular shapes will be distorted. So what he drew there is a parabola, but for some reason it creates a long oval rather than what we would see as a parabola. I also disagree with that assertion on a flat
Well, you can
we would
do.
still see a parabola as a
You
parabola.
are free to.
I
That's
think so.
science,
I think
because
he's
it's a
wrong about
massive
that.
topic in science, which none of you clearly understand. There is a massive issue and talk about is perspective curvilinear or actual linear. And there is scientists saying one and scientists saying the other.
Right.
That's science.
The fact that we disagree means that we agree with some particular scientist, right? I don't give a shit about their opinion. I'm saying I disagree with this particular person's assertion because
bro.
shapes would appear different on a flat Earth.
Okay, now cite me one that would say. Now cite me one that would say that there would be no horizon on an infinite flat plane.
Yeah, that was Gleam responding to you, providing nothing, BioDuel. So provide something.
Oh, I'm sorry. Let me just do what Brandon does. I don't think you're right.
That's my response to you saying I'm right.
If you grab any video game, it's created on a flat plane, and every video game has horizons.
It doesn't render fully all the way. God damn. You're going to use video games that don't render
They're not
the
going to
entire map?
respond.
God damn,
It's kind of obvious, right?
People, bro.
Perspective. It's
Just
simple.
admit you're
But
wrong,
then Brenda comes,
Bioduel.
hold tight, my friend. Brenda
am I
comes
wrong
on
about?
to
Hold
the
on, go ahead,
horizon
Jedi.
is caused by Earth curvature that we don't see that can only be
Oh,
bent
man,
with
I gotta get out of here.
Guys, if you hear someone else talking, please don't talk. Jedi, go ahead.
It's really simple. You see it everywhere in computer games, like our friend just mentioned. People who understand the world know that perspective exists. But people like Brenda come in here and say the horizon must be physical, but a refraction of a physical location, just to fit her narrative. It is bollocks. You do understand that, Brenda, don't you? Just
Jedi,
say
you
yes or
understand
no.
that video games are a horrible example to use for reality, right? Because our reality isn't rendered based on our vision. The video games are rendered based on that.
Well, when a perspective
So
expert
fucking dumb.
explains it to you, and then you claim that he's wrong.
He's not an expert. He's a
where do we
mathematician.
go?
Wait.
He's a mathematician explaining
negated all the Rufus models.
If you want to go, but this perspective expert, your horizon is where, Glenn? Remind me.
Depends on your height.
I
I just told you. I just told the equation.
Fucking shit about height. He said that infinity.
Exactly.
And it would create a horizon. Is that going to create a horizon, Chike, or not?
Infinity.
Are you
3
panicking now?
miles.
Are you spiraling just like her?
No, 3 miles away far from infinity.
Do you need citation coming
Hello,
out until
Glenn.
you die?
I'm talking about what your professor said. Here we have this point.
Yes, he said there would be a horizon. That's what he said. And you said there wouldn't be.
At infinity, he said.
No, he didn't. He says here, I've cited it in the general.
literally said
There'd
at
be a
infinity.
horizon, and here would be the x-axis.
Infinity.
No, it says x-axis and y-axis.
Watch the video again.
Why is infinity got to do with it anyway? Isn't infinity the horizon? Look at you idiots.
Exactly.
You're
You know,
arguing
these guys
for the thing that you just denied.
They don't get it, do they? They don't get it. Sleepwalking still.
They only prove I told you they're the best flat earthers ever.
They're liars, though, and I don't see why you have to lie. If it's a globe, there's no reason to
Tell
lie
me
about it.
who's an idiot now.
I've not heard any
Tell me
perspective.
who's an idiot, Glim.
You are an idiot because you said there was no horizon, and no professor would say that there would be one on an
This
infinite flat
line
plane.
will go toward this point at infinity. See, at the horizon.
I just said the horizon is infinity.
Wow.
You
The horizon is infinity. Oh, that's all we need. That's all we need. Thank you.
Infinite compression. Yes.
Right. You can bring it back with the telescope because there is no true horizon. You can always bring it back. Thank you.
No, you can resolve more.
Ding, ding, ding.
You're done just
You
goofed.
don't
Thank you for getting that. Thank you with closed captioning and everything.
You're idiotic. So you just still don't even get the
I tell
cube.
you what your professor said on the video you brought, and now you argue against it? What's up with you?
I
What's
just
up
agreed with you. Infinity is the
what's
horizon.
up? No, he put this point at the horizon at infinity.
Yes, that is your central perspective point, which is your what's known as your vanishing point at infinity.
No, at infinity. Right.
So is it
That's
at
where the
infinity
horizon
across all that
50
line?
miles. You could
Is it
resolve
at
100
infinity
miles. You could
across all
resolve
that line?
2,000 miles because the horizon is infinity. So
No,
you could
wait there,
resolve
wait there.
2,000
Why are
miles.
you just panic asking questions or not answering?
No,
Is
this
that
shit's
whole
funny as
line?
fuck, man.
Is that whole line the vanishing point?
No. Why? Well, it could be potentially, depending on the equipment that you're using, of course.
That is hilarious.
But you can resolve it by using different equipment, and you can change that vanishing value. Are you?
Yes, you can. I'm not denying it. I'm not denying that. You're denying that horizon line can exist on an infinite flat plane.
Oh yeah,
yes?
no, it doesn't exist because I would just change the equipment, and I would bring back things. that
No,
are
because
further.
then another one would, based on that equipment
Right, and I would just make better
limitation.
equipment infinitely. Yeah.
And so you've got an infinite lens now.
Yeah, you have an infinite plane, and I have an infinite lens. Exactly.
And how does obscurity come into this infinite plane?
Stupid.
Sorry, guys, I'm behind on the super chats. Apologize for that. Rodney B, 999. Refraction is real. Terrestrial refraction based on an unmeasured radius value is not. Prove me wrong. Yeah, no doubt. My point was, what is the baseline? What do you measure it against? Oh, I don't know. I still don't think you can optically prove the shape of the Earth one way or the other. You especially can't falsify their model because, unless you just say that you don't have anything to back up your R model, because they've made it unfalsifiable. Silent Zero, $5. Good day, Brandon Rumpus. The Earth is very flat. Thank you, Silent Zero.
Rubbish.
Rubbish. Great
Rubbish.
rebuttal.
It's absolute rubbish.
Great rebuttal. Great rebuttal.
It is rubbish because he's blatantly drawing a horizon choke. What don't you get? You said you can't draw a horizon because there isn't one.
There isn't.
Infinity.
So why is he drawing a line? Tell me why that is.
Here, let's
That is
just take this
amazing.
logically. Let's just take this logically.
You
A
are
horizon-
seriously
a horizon is where
denying
where the ground meets the
denying
sky, right?
reality.
If this is what you call a horizon goes on for infinity, where does it meet the sky if it goes on for infinity?
It's an optical illusion, as you well know.
Oh, I'm sorry. I'm sorry. Was that a proper response? No.
At your
Where does the
resolvability
ground meet the
power.
sky?
At your
Where-
resolvability power. Why are you asking questions? Why are you not
are you
answering
adding to
them?
the definition? Because I'm just asking.
No, it's called
specifically
resolving
on
power.
an infinite ground, on an
No,
infinite ground,
yes,
where does the ground
it's
meet
called
the sky?
resolving power. If you could only see, let's say you're an old granny, yeah, that horizon would be nearer to you than a young fresh kid.
Beautiful. So when we do this over the water, and I'm using my eyeball,
same
and I
height.
say I can see 3 miles away.
No, but
then I
why?
bust
No
out my
one's
telescope.
answering why
can't I
that
see
line
5
has been
miles away?
drawn on there, and
Because
he
it's not a
calls
flat
that an
line.
horizon.
There you go.
No one's answering that. You're just ignoring it and moving on to your
Well,
own
I'm not
little
gonna
line of
argue.
questioning.
If we assume that this person is correct, then what you're saying is it's only the
liked him,
resolving
remember?
power. It's the only resolving power of our equipment that we're using. So what I'm saying is, when we go to the beach and we look out and we look at this horizon, whether it's infinite or not,
You know this
and
guy's
I
a
can see
globe
3
earther,
miles.
yeah?
I know you want to interrupt me because you don't like the conclusion.
No, he's
So
a globe earther. I'm saying he's not a flat earther.
So I use my eyeballs and I can see 3 miles, right? I can resolve 3 miles. Then we're going to use a camera, and now I can I could potentially resolve 6 miles, but I could still only see 3 miles. Then I use a telescope. I could potentially resolve 100, 200, 500 miles, but I can still only see 3 miles. What's the problem? It's not an infinite horizon. It's not an infinite plane. It is a spherical Earth.
Model.
Height. Just told you. Height. Now, can you answer why he drew a line?
Why does the video not have a z-axis?
No, we're not going on to more questioning when you can't answer one of my questions. This is not on. A conversation is supposed to be answer and ask.
No, you're right.
And you're just going, I want to give you a quiz. I want to give you a quiz. I want to give you a quiz. And before you can even get one in, tell me why there is a white line drawn on the blackboard, please.
Oh, because we can't draw infinity. So he's
is that a no horizon? Is that the horizon?
He's drawing. I'm going to answer your question. He's drawing the line to represent a horizon that extends infinite. Just like when we draw a graph, we understand the x and the y-axis go on.
That's all I needed.
And you draw
so
an arrow.
He is drawing a horizon, is what you're saying.
He's drawn an infinite horizon.
Yes, so it's a no horizon. If you look up the definition of horizon, infinity is in there. No, you can play with that all you want, because 2 minutes ago, Brenda just told me it's impossible to draw that line because you cannot represent a horizon on an infinite flat plane.
Whatever you want.
And he just did. He just did. And that is my point proven. Thank you. Now, go and learn about the cubes. Rewind this and re-listen to it, because you've got to get that concept first.
So again, we can play around that infinite horizon, though, because if you're saying that it's height that's involved, I don't see a z-axis on the guy's representation here.
No, you don't.
If we understand
because that's irrespective of height. So the more height you get, the more distance you get, because the greater the angle you get.
Why? What's the problem with the angle there?
Because you see.
I just told you, the greater the angle you get.
What angle?
You're all panicky. Why?
I'm not
because we could change the angular resolution limit. We can change that with our optics that we use. We don't have to change height. We don't have to change height. Fuck height. All we have to do is change the equipment that we're using, and we can resolve it because we're changing the angular size. So if you're talking about changing the angular size because we're increasing our height to that object,
I'll tell you what the problem is, Bio. Let me answer him. So the problem here, Bio, is that it's going to depend on the size of your lens, right? If you're going to make it bigger, that size of the lens has to increase. And at one point, the center of that lens is going to be on a higher altitude. And if you want to increase it more and more, that altitude is going to go higher and higher because of the equipment has to be bigger and bigger.
No, it doesn't.
Yeah.
Oh, my God.
I'm going to use a telescope. How big is the lens on a telescope? What altitude do I have to be?
And that's going to have a limit, you dumbass.
At what altitude do I have to be to use a telescope? Because the lens is too big. Think about the words before you use them.
Point, huh?
I have a question for
Put it this way: you've tested none of this, have you? And
you're
just airy-fairy throwing any shit at the wall, hoping something hits.
I have a question for you, Glim, now. So why did the ship?
No, because you haven't admitted that you were wrong, Chike.
No, I was.
It's bullshit speaking to you because
absolutely right. You were wrong.
No, that's wrong, because your friend who was just backing you up has just said he drew a line on there because that's the horizon.
There's
no point speaking to you. No point. No, I'm not going to answer your questions if you're going to lie and then not be honest.
I don't fucking care if you answer. You will hear my question, though. So why is the ship disappearing when the observer is at 25 feet high, has a 90 millimeter telescope, with 600 millimeter. Shut the fuck up! I'm talking.
I'm answered before you even need to carry on with your big list.
600 millimeter focal length.
So Glenn, how's your day going?
Why did half the ship is missing?
How's your day so far, Glenn?
Cool.
Is it good?
Yeah. Cool. Resolved the little issue with a dashboard.
And what was the original claim that your eye can't make a horizon on an infinite plane? That was the original claim by Brenda.
Yeah.
No, I made the original claim. I said there would not be a horizon on a flat plane.
Okay, well, all three of you are wrong then. and not
No,
one of you are willing to admit
by
it.
describing something to infinity, there is no horizon.
What
It's
are the
infinite.
conditions that
There
that
is
is
no
true?
end. There is no
What's the
point. There
conditions
is no
that
point
are
where
true,
the sky
That
Bado?
is your
ground.
horizon. Your end is your optical limit.
No, the sky never meets the ground with an infinite
What are the
horizon.
conditions where that's true,
I mean,
Biodual?
You
There's
guys,
no
are you guys
conditions in
saying
reality. You're right.
Are you
Yeah,
guys saying
because
that in
we
a
have the atmosphere, we have an uneven surface. The visibility is usually only what, like 10, 20 miles at most?
Oh, I'm sorry. I thought we were talking about water over water because remember
Even
it's
over
always flat and
water,
level.
you can't see that far.
Yeah, because
Never
it curves.
flat over water.
You're right.
Huh?
So in this model where you have the horizon at infinity, is light not bending in this model, or is light bending?
Oh, that was a separate conversation. I think this was
Well, it's both.
specifically
You
for
don't
that
think
flat
it's
plane.
you don't think it's intertwined? You don't
Oh
think
yeah,
the
sure.
light
So
bending would
light
have
would
an
still
effect
bend.
on
The most
So
often
what-
effect. The most often effect would be looming. That'd be the most.
So it's
often
not
effect.
a separate conversation. It's the same
No,
conversation,
we
right?
we can, Jeremy. We just didn't
It's
bring up
it's
light
the
by
same
anybody.
conversation. How can you talk about the horizon without the light bending?
All right, that's fine. So the most common form of refraction is looming. So it comes up.
So
it
it's
would
the
make
same
it would make
conversation.
it would
You're an
make the
idiot.
land and the horizon come up rather than go down. So well played. Thank you for bringing that
Well,
up.
that's your assumption. You can't prove that.
It's proven with
I have-
refraction all the time. That's the most common form of refraction. You're doing great, Jeremy.
I have proved it.
What do you mean the most
You
common
three are
form of
doing
refraction? Based on
great.
what, Biodual?
Based on refraction experts, even Andrew Thomas Young said the same thing. That's the most
Based on
common.
the experts.
Yeah, based on the experts, that's the most common form of refraction. So we wouldn't see any physical obstruction due to refraction.
An
making
expert
it
just
appear
said you
to
were
go
wrong
down.
there.
An expert to perspective.
Based on the density gradient in the atmosphere, retards.
You're a retard.
You're a
Yeah,
retard.
everything works
You
against
are the
flat Earth.
biggest one.
At some point, it's
Seriously.
got to be realized, right? At some
No,
point.
it doesn't, because your number one assumption is always we're on the
It's
ball.
not going to be realized when you keep lying about it.
I'd like to ask Ruhif if he would weigh in.
Yeah.
With what weight?
I would just like his input on whether he thinks that on an infinite plane you would have a horizon.
Why? He's
Ooh.
almost as dumb as you are.
Could you model it?
We-
Could you model it? Model it.
In fact, I should get the thing I sent to Brandon a few months
guys.
ago, showing mathematically that the horizon should rise to eye level on a flat plane and doesn't. In reality, though,
So there is a horizon on a flat plane.
Well,
Oh my
what I
God,
was gonna
Brenda, that
say
was that was no weight.
what I was going to say was that I don't think there is a horizon on a flat Earth, right? Because what I now see as a horizon is the thing that we look at to see how much is missing of an object behind it. That doesn't make sense on a flat Earth.
Exactly.
So you can't be 1 foot and there'll be a 1 foot object and that covers more of 1 foot with another object further
the
away in the
horizon-
background.
What are you talking
It's-
about?
Overlapping. You obviously don't know what
What's
that is,
overlapping?
Brenda.
Oh, that's right. I read your fucking... What is overlapping error on that comment that you made last night?
You seriously don't know what overlapping is. I've just explained it with 2 cubes.
What was your explanation?
Okay. You have 2 1 meter cubes. You are a 2 meter person. Yeah, your eye level's at 2 meters. 2 meters in front of you is the first 1 meter cube. Then 2 meters beyond that is the other cube. Because you're higher than that, right in front of you, you are most likely, I haven't actually done the maths, it was just a thought experiment, but you are most likely going to be able to see the bottom part of the second cube above the cube in front. Now,
Probably, yeah.
yeah. Now, either way, if you put it into a configuration where that happens, okay, you are above both objects still. You now keep that equal proportion of them two, but then push them both off into the horizon. Because they're
So
both
what's
appearing
this
to
got to do with
rise,
the angular
are
size
you
of
just
the mountain?
interrupting and just not understanding it and just then just
No,
going to
I
ask me again
understand.
tomorrow?
You're talking about occultation, which is the new buzzword. But how does that change the angular size of the mountain? Sorry, this is a bit of a...
You're changing topic now. What's the angular size
No,
of the
this
mountain
is
got
the
to
topic.
do
It was
with
your
overlapping?
comment.
No,
It was
you
your
just
comment
said,
about the angular size of the mountain.
you just said, yeah, that the horizon is what I judge as stuff being hidden behind. So basically, Earth curve. Yeah.
Yes.
Now we know, Ruhif, that you can be 1 foot off of the floor. You can have a 2 foot wave, a higher wave.
Yeah.
And that will cover lots, wouldn't it?
Yes.
So then that wouldn't be the same thing, would it? Really? But that would be your horizon, wouldn't it?
For the context for everyone else, I asked Gleam what is overlapping error when it comes to the angular size of the mountain that we talked about yesterday. That is the context. So how does
you
that
just butted
change
in.
the angular
You
size?
just butted in on a conversation when we're talking about the horizon.
I
And you
understand
said
that this
you
is
said
gonna
yes,
be
the
lack of context for
horizon.
everyone
La
else.
la 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 la. Yeah, exactly. So you've just changed the whole topic because you're stamping your feet, throwing your toys out your pram because you don't understand occultation that you just said
do
you did.
understand occultation. You called it fucking
So
overlapping
wait there.
error.
So
I was like,
yeah,
what the hell is
exactly.
overlapping error?
Well, that's what the professionals call it.
Well, I
The
googled the term and
experts.
I couldn't find any hits.
Okay, well, there's a NASA scientist who works in the University of Salford
Good
who
for
has
you.
a paper who calls it overlapping. So that's who I've got it from.
Right. So how does it change the angular
I've
size
cited
of
you
that
the paper
mountain?
though, Ruhi, if you know that, yeah?
You probably have. Cite it again.
It's perspective distortion modeling on image measurement.
Oh, yeah.
You remember
People's
that one?
perception. That's right. People's
No,
perception.
absolutely nothing to do with it because it was a camera. The guy's a robotics engineer for NASA, you twat.
Oh, so not the one I'm thinking of.
Oh
then.
my God. Seriously, look how you panic. Look how
Is
you...
that the one where
Yes,
You're
no,
just
I'm having a
desperate.
panic attack
You're throwing
right now.
shit. You're throwing shit at the wall, hoping it will
is
stick.
that the one
and
where
it ain't
Gleam
gonna.
didn't know what a rangefinder was?
No,
That was yesterday.
absolutely.
That's right. Gleam claimed there could be a 3% error in my calculation of the angular size of the mountain because of this guy who did an actual measurement of this door frame and then used a camera, like used a photo.
Measurement
I'm speaking now. I'm speaking now.
Yeah,
You got
but
shitty
you're
with me for
omitting-
interrupting, so
you're
I'm speaking
omitting
now.
information.
I'm speaking now. I'm going to keep speaking because you're interrupting.
I'm smoking.
So he measured the actual door frame and then took a photo of it, right? And his measurement was 79 inches and his calculation from the photo was 77 inches. So there was like a 2 or 3% error. The
2.5% error.
Right. But the error came from the fact that he used a rangefinder to estimate the distance, not the fucking photo. That is retarded. You are a retard.
Incorrect. He knew the distance. Go reread
he used
it.
a rangefinder
Go
to find
reread
it.
it.
I did
He
read it.
used the rangefinder, yes.
I used the rangefinder, which has
Yes.
an error of 3%.
Now go reread it, and he said
I haven't
he
reread it.
physically measured it. He physically
He didn't
measured
say he
the
physically
distance.
measured it. He said you could measure it, but he used a rangefinder, which is inaccurate. So therefore, his measurement from the photo
was
incorporates that inaccuracy
Okay.
from the rangefinder. You are
So
a retard.
how accurate are your measurements on Google Maps? This was the whole point of it.
My distance measurements on Google Maps
If your
or Google
dis-
Earth, sorry, are
if your
incredibly
distance
accurate.
measurements are 6 miles out, yeah, that would account for this. There we go. That would account for the missing amount.
Distance measurements on Google Earth are incredibly accurate.
No, they're not. They
Yes, they are. Go and
literally
measure
tell you
fucking runways,
themselves.
running
We
tracks,
do not
anything
guarantee
that
any
has a known
accuracy.
distance. Go and
They
measure
tell you
it.
themselves they don't guarantee any accuracy.
Of course, I don't guarantee it, but they are accurate.
Okay.
Yeah,
Go and measure as many runways as you like. Anything that you know the distance of, go and measure it on Google Earth.
Mm-hmm.
In fact, go and find a fucking straight road for 20 miles.
I measured this massive 30-mile Pac-Man in the middle of Antarctica. Is that there?
What the fuck?
The only
Yeah, I
thing
measured that.
Google
It was
is not
30 miles.
accurate
Right
for is elevation.
Correct, Rumpus. Good morning.
Morning, Rafe.
Are you sure?
yes,
I'd look that
yes,
up.
I
I'd
gleaned
look
the
that up
size of
before
this
you make
thing as,
bullshit
he
claims.
gives examples as to why this photograph.
Yeah, ignore
I
the
knew-
other one.
I knew
Ignore the
there
other
was a flaw in it,
citation.
and I couldn't remember
Ignore
what
the
it was.
horizon
And then it
comment.
turns out it's this rangefinder. So the camera and the photograph are perfectly accurate. The only thing that wasn't accurate was a rangefinder, which had absolutely nothing to do with the point
Incorrect.
that Glean was making. So he's
Incorrect, because if
absolutely
the
wrong.
rangefinder was
Absolutely
3% wrong,
always. You can
the
guarantee
calculation would be
Glean is wrong in
3% wrong.
everything he ever
I don't think
claims. And the
I don't think you
3%
guys
error
have
is
ever
in the
allowed.
rangefinder, not in the trigonometry.
I don't think you guys
No,
have ever
you're
allowed
blagging it.
him to explain this, so any of the rest of us understand it. Every single time you guys interrupt
put it
him.
this way: I cited two things, and they haven't even mentioned the other one.
What was the other one?
I'll cite it again. I'll cite them both again.
I've just posted the range.
Just the scan tips. If you remember, Ruhif,
they're gonna become flat earthers.
if you remember, Ruhif, it's the guy who made his own calculator, yeah, to calculate objects in the distance. That guy that you said it's a shitty calculator, yeah, which
I don't think
actually
I said it was shitty. I said it was overly complex.
no, you said crappy was your exact word. I don't care about a crappy calculator
Because we
online.
don't need it, because we have the information from the photo.
Okay, I don't think you do. There we go. In the general chat, he's basically talking about calculating measurements or making measurements and citing him. Or if the camera
how
is
did you
aimed,
quantify the error?
I'm citing him. Or if the camera is aimed up or down, the same effect, which is basically in brackets, plus or minus angles are the same effect. That angle causes object pixels to optically measure shorter than it actually is. If you kill it, and he's talking in the context of tilting your camera and causing
or the
a
object,
foreshortening effect. Okay. And then he goes on. He goes on after he's done his measurements. He goes on to say the camera obviously achieves its camera purpose, but it simply is not a measuring instrument.
Oh, hang on,
Do you
hang
not
on.
wait there?
You missed a
sorry,
word.
I did a
You did.
precision, a
Thank you.
precision measuring instrument. Sorry,
How
I knew
fucking
that was
dishonest
coming
that,
up.
Glenn?
So, yeah,
How
no,
dishonest
sorry,
is that?
I apologize. No, it wasn't dishonest. It was a slip because I was rushing because I needed a cough. I swear to God.
Okay.
Yeah, so I'll go back again. The camera obviously achieves its camera purpose, but is simply not a precision measuring instrument. Do not kid yourself when the calculator shows precision of a couple of decimal places. If you do need precision measuring, you should get a different instrument intended for the purpose.
But this
Right.
guy's clearly
Can
a
you
moron.
quantify-
He's using a rangefinder with a 3%
No, that's
error,
a
and then using
second.
that as an example
just
as to
throw
why
any old
photograph
shit.
can't
Talk
make
about a
cameras
completely
work.
different site.
He is
This is
clearly
a second
moron
citation.
if the error is in the rangefinder and not in the photograph or the camera. So we
Yeah, it's a
See, I
different
love
citation,
this. I
Rumpus.
love this. This is
You're
amazing.
talking
You've just
about
done
the
the
wrong
same thing,
thing.
though, Ruhiv. Ruhiv, you just come in and changed the topic to this again. And completely
Fine.
changed it from Brenda
Yeah.
and Chike and that other guy being wrong about there
but
being
he
a
already
horizon.
embarrassed you about
Now,
that.
Glenn,
He already embarrassed
No,
you.
quantify-
you have been shown wrong. I cited you wrong and you haven't cited anything back to me, so I can't believe you. Sorry.
Quantify this tilting effect that you just posted.
He's got a
with
calculator
respect.
on the side. It's a very small effect. Yes.
Thank you. It's a very small effect. I would
Yes.
say negligible, less
Yeah,
than a
ignore it.
pixel.
Yes. But when you have
Right.
many negligible
Excellent.
effects.
So it's not 0.05
No,
degrees.
no,
is
no,
it?
no, 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 wait there. Hang on.
Quantify it, Glenn.
That was my point.
Quantify it with
That
respect
was my
to the
point.
photo.
No, that was my point. You haven't quantified it. And now you're
I
saying,
know that it's a
I've done the
negligible
work here. I told you that this proves something. And then when I've come with a complaint about it, well, you haven't done a proper job.
don't believe
You
you
said,
quantified
well,
it at
you do everything for me then.
You have not quantified it, Gleam.
It's
You've made it up.
quantifiable. We've just said
Here we go,
negligible.
You see, there he was. He was complaining that Ruhiv hadn't quantified it as
Oh.
though he had done it, and he hadn't. He's just guessed.
I've
what
just
it is,
cited
and
it,
it's so
Rumpus.
small,
Rumpus,
we can
pull up that
ignore it.
link in the general chat.
I
Pull
know
up
it's
that link in
negligible,
the
Glenn.
general
You
chat.
know
I've
it's
just
negligible.
cited the maths for it.
We know we can ignore it. Those of us.
No,
who
I've just cited it. You're
No,
throwing
we
shit
can
at the
ignore
wall,
it.
hoping it. No, you cannot ignore it because it
Understand.
matches
Yes, you can.
Ruhiv's calculations.
We know we can ignore it.
I can ignore anything that is negligible.
Yes, and multiple
Right.
things
Is
that you
this
ignore that are
negligible?
negligible mound up.
No,
It's
they
your
don't. That's
job
they
to
can make
prove that
negligible.
they are significant. Go right ahead.
It's not.
You haven't
Go ahead and
quantified
prove
it,
it's
Gleam. You
significant.
haven't made a case that it is worth taking
In science,
You
yeah.
just
Let me
made up
ask you,
those
you
numbers
three then.
because
Let
you
me ask
haven't
you
done the
three.
calculation.
Another three
You gave
versus
the
one.
impression
I'll
you've
take
done
you
the
on. Come on.
calculation.
I'll take you on. Come on.
You
Let me
just
ask you a
guessed.
question.
You
I'm
just
just going to
guessed.
explain, Rumpus.
You
No, I'm
made
just going to
those
explain.
numbers up.
I'm
You
just going to
made
explain,
those
Rumpus.
numbers up,
Can
didn't
you stop
Gleam?
talking, my man?
You made those. Well,
No, I
admit you
didn't.
made those numbers up.
No, I
Admit it.
didn't. No,
You did.
I did not.
You
I
didn't
did not.
calculate them, did
No.
you?
No.
You did not
Go ahead,
calculate
explain,
those numbers.
Gleam.
You just
You
made
didn't,
them up.
you didn't calculate them. You just said 0.05 and you pulled it out of your ass.
Wasn't there a? It could
You're a
be.
charlatan.
There was a
It could be.
massive.
Okay,
There was
so
a
you didn't
massive
calculate
capital
it, all right?
letters. No, listen. Exactly that.
You didn't
Exactly.
calculate it.
Are you going to
made
allow me to
those
explain it?
numbers
No, I
up.
didn't. No, I didn't.
Okay.
You did.
No, I
You
didn't.
calculate them, did you?
No, I did not. You
But there
dickhead.
you
Can
go.
you
If
let
you
me
didn't
speak
calculate
it?
them, you must have made them up.
God. No, I did
Jesus
not.
Christ.
I did not make them up.
Rumpus, shut the fuck up and let him explain.
Oh my God, he is so panicky. This is so funny.
You
Do you want me
just
to?
really annoying when
Calculate it and come
someone's
back with the
basically
numbers,
lying
man.
to us.
Oh, you're just
Let him
over
explain.
talking me just to
Go
stop me
ahead,
from
Gleam.
explaining. Why do you not want me to explain, mate? Seriously, let me actually cite. Let me cite because it was from yesterday's show, Brandon, in the notes. I put up a thing, and my whole point yesterday with bringing up all these additional things, and this is my question back to these three gimps. Yeah, in science, if there are known effects, known phenomena which can affect, doesn't matter how much, can affect your observation, should you include them to eliminate them, or just go, meh, I'm just going to
If
forget
they're
about that?
negligible, you can eliminate them.
Right, Rumpus. Repeat what you just said, please.
If an effect is negligible, the definition of that means you can ignore it.
How do you know whether they're negligible if you haven't calculated for them?
It's your job.
We know
William, it's
they are
your
negligible.
job.
You're all talking at the same time. This
Go
is
right ahead.
not very good. Rumpus. How do you know they're negligible
Because
if
the
you
effect-
have not done the
Three of the
fucking
effects that
calculation?
were complete
you dick?
fiction, and the other one about tilt is known to be
You're now
negligible.
panicking. You're not answering my
No, I'm
question.
You made
You
stuff up,
obviously
you
don't
didn't
have
do
an
the
answer.
calculation,
You don't have an
and
answer.
Three of the effects you talked
Right.
about were completely
Let me
made up.
cite exactly what I said to Rumpus. Yeah. So because he's saying he's making up some other bullshit
made up
which
some
I don't know. No, you are crazy. You are
No,
literally
I just don't believe in
panicking
geometry.
here.
You're a geometry denier. You
This
don't
is-
understand how to perspect it.
Yeah,
You've demonstrated
correct me
time
if
and
I'm
time
wrong.
again
This is what you
don't
cited me
understand
back,
geometry.
Rumpus. Listen,
You've
listen.
demonstrated time and time again you
And why
can't
are you panicking? Why don't you want me to tell everyone this? Is it because you're panicking?
Finish my sentence.
Your sentence. That was fucking a book, mate. Anyway, I said floor compression, and then in capital letters, on its own, will not account for the missing 0.2 degrees.
Floor compression is not relevant.
I haven't
to
fucking
the third
finished,
floor
you
effect.
absolute baby.
Here.
Stop throwing your toys out
ahead.
your pram. Floor compression, capital letters, on its own, drop lowercase, will not account for the missing 0.2 degrees. So I agree with that.
It accounts for zero, Gleam.
Oh, for
Zero.
fuck's sake. And then comma. However, it, in capital letters, could account for 25% of that being 0.05 degrees. Now, Rumpus is in here. I've then listed 4 other effects. Camera tilt foreshortening, camera lens error, angular size error. Yeah, I've listed those, and I've said the same thing. On its own, individually, they cannot account for all of this. I agree. But if you add them all up, and if you at least calculate for them, then no one can use that as an excuse of saying, oh, it's compression. Oh, it's lens. Oh, it's to do with refraction. If you account for everything, then no one's got an argument, but you obviously don't want to. Because
Your
there's
floor
some that
compression
you probably
and camera
actually
tilt are
calculated
the
it.
same
'cause-
thing.
Mind if I
You
have
can't
just a
both of
second
them.
here then?
No, you're absolutely wrong. Absolutely wrong.
Yeah,
Go
go
away
ahead.
and
The
learn.
camera tilt,
Go away
the
and
camera
learn.
tilt is a perpendicular object leaning away.
Right,
Your
Ruhith,
floor
answer my
compression is
one
a
question.
parallel object.
Answer my one question. In science, do we account for all effects that can possibly affect?
They are not effects.
No.
They do not count at
Experiment.
all. They are
No,
zero.
we do not.
They are
They are
zero.
They are not
negligible.
zero.
They
He
do
just said
not
there was a
affect-
pixel. That's
They
not
do
zero.
not.
do not.
You made up some things which are not relevant.
No,
They
I
are
didn't make it
zero.
up. We just established
They
that
are
you were just
zero,
bragging.
Gleam.
I was just saying it could
The
be
fact
this,
you're
it
talking
could be
about
that,
form
it could be
compression,
anything. You don't know
don't
because you
understand
haven't
we're talking about a
calculated for
vertical
it.
Object. It has zero effect. Absolutely zero.
You're talking out your ass.
No, you
Glenn,
don't
You're
understand
telling
effect.
me, right?
You
You're telling
don't
me there
understand
is no error deviation in these calculations.
Glenn,
Are you telling me there is no standard error deviation at all?
Gleam.
You are bullshitting
You
and
don't-
lying to everyone. That
You
is
do not understand
anti-scientific
geometry.
to say
You
there
are
is no
making-
errors.
You are a geometry denier. You're making stuff up.
Anti-scientific to
Those
say there is no
tried,
errors.
That list of four
Gleam.
things had absolutely nothing to do with the effect we're talking about.
Prove it. You can't because you
Okay,
haven't done the
okay,
maths.
we'll go through it then if you like. We'll go through the geometry.
I don't want to. I don't want to, mate. I'm just highlighting that you can't be doing the fucking full job.
Right, so here we go. We can tell he doesn't want to talk about those four claims he made, and because he doesn't understand them, Ruhif and I can easily invalidate those four things
then,
that he
do
claimed.
it. Go away
He
and
doesn't
do it.
want to talk about them. What does that tell you?
No, I've talked about him for fucking years, mate. But you haven't listened.
yeah,
I've cited
but they're
papers for
gibberish. Yeah,
years,
but you don't want
and
to
you haven't
analyse.
learned a fucking single one of them, mate. It's hilarious.
You don't want to have them discussed in front of people where we would demolish them.
Rumpus, why have I been discussing it for two
I'm
to 3
not
years
aware you've been
live?
spouting this drivel until
I've been
recently.
doing it with you twat, talking about your
Hey, Rumpus,
stupid
can I have just a second with this guy?
diagram
Yeah, go
where
ahead,
you
go ahead.
don't account for any optical limits.
Yeah, and it's
All right,
gibberish. You keep on fighting these psychological papers have nothing to do with perspective.
Rumpus, can I
Optometry
have a second with this guy?
is the science of perspective.
Your mic's a little low,
Can I
Bob.
see your globe?
Rumpus, he's a science denier.
Bob, you're a
He is
liar.
science denier. Agreed, he is a science denier.
I'm not. I'm supporting science here.
No,
I'm
you're not.
saying
No,
you
you're
should.
Don't buy
You're
into
the
his
science
science
denier.
denier bullshit.
Four claims he
I want
made.
to support.
Go ahead, Bob.
You're the
You're-
science
me,
denier.
Brandon?
Yeah, Rumpus
Hey,
is
hey,
the
hey,
science
guys.
denier.
No, you're
saying
really
we can
low,
just
Bob.
admit everything.
Brandon, can you hear me?
That's better now. Go ahead.
All right. Gleam. Here's the problem with your entire argument that destroys it. There are always errors in scientific measurements. Some of them we're aware of. Many of them we're
That's
not
different.
aware of. We're not aware of these things because we don't know enough about the measurement. We may miss something that we're not aware of. The way science works is if you have a problem with a membership or a measurement, and you think that there's a significant effect that we're missing, you go out, you get the data, and show that your
Bob.
error is significant. Until
disagree.
then, we can disregard you.
No, I disagree. And do
I
you
don't
want to hear
care.
my reasoning?
Obviously.
I've got reasoning. The reasoning is when you say at your beginning of your sentence, there is always error. And then when I ask Ruhif, show me your accounts for error. And he says, none. There is none. There's
I
a
said it's
complete
negative.
We
You
do
fucking liar.
not have to account for every potential or theoretical error in a measurement. We can make a judgment as to whether or not it's significant. If you disagree with that, you
And
can
Gleam-
calculate it out and figure it out and show that it's
How,
significant.
did I say there was no
Okay.
error?
Yeah.
Did I say there was no error?
Where is your calculation for the
Gleam, did
error?
I say there was no error?
Where's your calculation for the error?
Did I say there was no error?
Well, you haven't got a
not. We did
calculation
not
for the
say there
error.
was
We
Did
don't
I
have
say there
to
was no error?
calculate it. You have to calculate it. You're the one claiming it's significant. Show us it's significant. We've assessed it and decided it's not significant.
You
Show
haven't
us
got all the
you're wrong.
information. You haven't got all the information of the thing anyway.
You
We'll go
can't
put it
We know
together.
this.
calculation. I do
What
really
zoom was he at? What zoom was he at? What's the focal length? Silence.
We don't need to know.
Yeah,
Oh,
you don't need to
It
know.
doesn't matter.
Yeah, we don't. Yeah. No.
The context of the
Why should we?
panorama.
No.
You're still
I'm
talking about the
sorry, but I'm going to
panorama.
trust that guy,
Hold
that
on,
Wayne
you're talking
Fulton,
about
who's
the
a
panorama
professional
picture, are you?
photographer.
Are
Who's
you
a
talking about
professional
the panorama
photographer
picture?
who said that you do
Are
need
you
to
talking
know
about
that
the
information.
panorama
It's very
picture?
No, we
important.
don't.
Rubbish in, rubbish out.
Are you
That's
talking
what it
about
is.
the panorama picture of
Yeah.
yesterday? Is that what the discussion is about?
Yeah.
You've
Yeah.
got
What's the
four
zoom
effects on that.
levels?
No, not the actual wide panorama, just the close shot, the single image of Grand Ferrand.
Right.
I was talking about a panorama.
So none of the factors you pointed out in your 4 points have
stitched
anything
together.
to do with it. It's completely irrelevant. Now, if you're so the
Yeah,
error
we could
about the
just
lens
say
is
and
irrelevant.
pretend that, yeah.
The error in the lens is irrelevant because we, as Ruhif did and I did, we worked off the image and used Google Earth to work out the angle between 2 points, worked out the scale. So we don't need to worry about the error in the lens. Irrelevant.
Okay.
But you don't understand this. You don't understand
No, I
anything
do.
that's
I
going
do.
on in
I do.
analysis. You don't.
I
and you
do.
keep
I
on about
understand telephoto
foreshortening, which
lenses
has
only
absolutely
actually
nothing to do with the
show
size
true
of the vertical size of things.
representation
fact
at
you
the center
keep
of the
on talking
lens.
about foreshortening, because, and you mentioned it in some week or so ago when you talked about the colours of
You're
things moving in
panicking.
the Ranty picture.
Rumpus,
You
show
don't
me something.
understand that
Cite
foreshortening
me
has
someone.
nothing to do with the
Cite me
size,
someone.
vertical size of objects.
Cite
You
me
don't
someone who's
understand
tested that,
the
please.
basic geometry of the issues that we're discussing.
Show me a citation. I've shown you 2 citations which say that you're wrong.
No, you haven't.
Yes, I have.
No, you haven't. Not at all.
Yes, I
No citation you've ever offered has said that something about the foreshortening along the horizontal has got anything to do with the angular size of a vertical object, the vertical size of something and its angular size. The foreshortening to do with horizontal
Did you not
has
just
absolutely nothing
read
to
it?
do with the vertical size of something.
Or if the camera is aimed up or down, the same
That doesn't make
effect.
any difference.
The angle causes the object pixels to optically measure shorter than it actually is.
And it's fucking
Let me get this right.
negligible.
So you are claiming if I tilt the camera, it's going
Stop.
to change.
No, enough
the
now.
shape.
Enough. This is
Hold on.
madness.
Are you
This is
now
madness.
claiming
You're
that if you
absolute
tilt the
mad.
camera, that will
I've just
change
cited it.
the image?
I've
Is that what you're
just
saying?
cited it. I've just
Is that what you're
cited
saying?
it.
Please,
I've
can you tell me if
just-
that's what you're saying?
I've
You
just
mentioned
cited
camera
it.
tilt.
Yes,
What
I've
effect
just
are you
cited
claiming
it.
that camera tilt has on the angular size of the objects in the image?
A
Please tell me.
foreshortening effect.
Oh my God.
Which is negligible.
You don't understand the geometry of what you're talking about. You don't understand perspective. The
You're
camera
both
tilt
in a
does not
paradox
change.
because
The
Ruhif's saying
camera
it's
tilt
small
does
and it
not
is
change
there,
the
and you're
perspective
saying it
or the
doesn't.
or the image you're looking at.
Well, you need a lot more research behind you there, Rumpus, because this professional
you don't
photographer
have
is saying the
do you?
angle causes
So,
the
so
object
people, I don't know if you
pixels to
understood this.
optically
He's
measure
claiming
shorter
that if
than
you
it
tilt the
actually is.
camera,
And
it
he's
will
an image
change
scanning
the
expert.
images that you're looking at and their respective positions. That's what he's saying. That's how stupid he's being.
Can I share my screen? Because this is ridiculous,
of course,
beyond ridiculous. This is so horrible and boring.
Yeah, you're just spouting crap continuously. It's very boring.
I'm citing other people, which
you're
rids my
mistaking
own
what they're
personal
doing. No,
belief.
you're mistaking. You misunderstand the papers, and then you present them to us because and then you apply them to things like this image, and it's not relevant. You get confused. You don't understand what you're talking about.
Okay, let me.
Why do you always have to go down that road, Rumpus? Play this
Because
little
he has to.
psychologist
That
thing.
is the only road he can go down.
Glean doesn't understand
All right,
90%.
okay, you don't think anybody understands. If they disagree with you, they're
Okay.
dumb. You don't understand. Blah blah blah. Why do you always go down
Well, that's
that
usually
road?
the case, yes. But
Why
that
can't
is
you
usually-
just stick to the
that's
facts?
I can't
I
help
don't
if that's the
understand.
case all the time.
Yeah, can
Well,
I
I
just
thought
cite
people-
this without you interrupting me, Rumpus? Can you just mute yourself just for a minute? Because this guy, as I say, he's done his own little calculator. And he's, as I say, a professional photographer and an image scanning expert. So, foreshortening due to angular differences. This is a difficult problem. Try to avoid it. Can someone mute up because I'm echoing? The calculator does not compute foreshortening of the object due to the angle. The angle might be from the object to actual vertical or horizontal, or it might be just the rotation of the object itself from the actual vertical or horizontal. And the worst case is both angles. This paragraph words it has vertical difference, but the same is true as if it's horizontal differences too. Substitute either word. The camera is assumed to be level vertically. Then, if both the camera back sensor plane and the object itself are both vertical, then these are parallel at any object position. So there is no tilting effect. Plus or minus angles are the same effect. And this is, just to explain, just to cut in there, this is where you see buildings leaning in and leaning out. But anyway, the angles
Right.
cause...
That's what
Wait
you're
there,
talking
shush, wait there, I haven't finished. The angles causing the object pixels to optically measure shorter than it actually is. The correct multiplier computes the actual height dimension. This is a chart of angles, can be a foreshortening guide, which is the angle of the object of the camera. 0 degrees is level vertically or straight ahead, forward horizontally. And the chart usage is actual height equals the apparent measured height times the multiplier, which he's got a list here of all the angles and the relevant small multipliers. Okay, and he's got there. So you're saying this guy is talking a load of shit.
Right, this is a different issue.
Wait,
This is a different issue.
This observation.
You know what? I demonstrate
I give up. I give up. This is bullshit. This is
Gleam,
absolute bullshit.
Gleam,
Yeah.
I demonstrate the foreshortening compression effect in a small demonstration. And let me just to clarify, is it, Rumpus, are you under the impression that an object in the foreground that is below the observer's eyesight cannot block the bottom of objects in the background, bottom up?
So
that's your claim, right?
Sorry, could you repeat that?
So wait.
Let me finish. On all of your drawings, on all of your shut up. And all your orthographic, shut up.
Fuck off, Jake.
I was talking.
Shut up, Chikey. All your orthographic drawings.
I was in
Rumpus,
the middle of my sentence.
You claim that a 2-foot wave couldn't block the bottom of the boats, right?
Correct. It can only block 2 feet. Yes. So, for instance, if you have a boat that's 50 feet high, and you are say 6 foot high, and the wave is only 2 feet high, the wave can only obscure 2 feet of the boat. If you're above, so if you're 6 feet high, wave is 2 feet high, and the boat is somewhere in the distance, say 50 feet high, the wave can only ever obscure 2 feet, and it can only do that when it's right next to the boat.
On a flat Earth.
Yeah, okay. So again, that's bullshit. I demonstrate clearly that the convergence will happen. The convergence will happen based on the optics of the lens. When you're using a lens, especially a telephoto lens, you're going to have optical compression. Shut up, Chikey. You're going to have optical compression issues, foreshortening effects, and you'll never be able to measure the distance or the actual size or the correct distance with telephoto lens due to these anomalies and errors in the calculations because of the barrel distortion of these lenses and the refraction that you are intensifying as you zoom in. So these effects aren't accounted for. If you're looking, shut up, Chucky. Go fucking just go have a coffee cake and fuck off.
Fuck up. You keep on going.
You're a waste of fucking time. You're a bullshitter and you're a liar. I literally demonstrate. The bottom up. Shut up, Chucky. Shut up, Chucky.
I muted him. I
literally demonstrate in real time. I literally demonstrate in real time that these people are full of fucking shit. That you can have bottom. You have a bottom up. I just demonstrated in real. Rumpus, I already demonstrated with optics.
What you're saying is untrue.
Rumpus, shut the fuck up. I already demonstrated in real time with optics. You can create a bottom-up obstruction with telephoto zoom lens, dude. So this whole bullshit of bottom-up obstruction, I've demonstrated clearly over a level plane in small scale. Yes, I have. I clearly demonstrated it in real time.
What do you mean you demonstrated it? Where? Where's the demonstration, Authoritarian?
Yeah.
I'll put it in the link. 1 second.
No. So, Glim, I have a question for you.
I'm not answering you. I'm not getting any value from this.
In your citation, where is the angle to the mountain fall exactly on this table?
Like, I don't want to discuss it with you because I'm wasting my time, mate. I'm wasting my time. You're just going to pretend that I'm wrong, and then when I cite something, you'll pretend they're wrong, and then when you can't prove that they're wrong, I'm then wrong, and I've misunderstood it, and it's something else. It's impossible to get out of that rut.
Why are you scared?
No, I'm not scared.
Oh, you are.
That happened 3 times, and you're not even
Hey, come on.
On an infinite flat plane.
He doesn't want to answer your question, Chikey.
I posted a
simple question.
I posted a demonstration for you, Brandon.
I'll answer it as soon as you answer why you drew that horizon line, and there isn't one.
So where is this in this table?
No, you're outstanding. You're outstanding a question, mate.
Where will never account for?
This is one of those
Stop avoiding your question, and I'll stop avoiding yours.
What is the fucking angle to the mountain? Where does it fall in the table?
Just keep answering it and maybe throw your toys out a little bit. That
Let's
might
watch
help.
this
Yeah.
demo.
Right, 'cause you don't know that angle from the photograph. You couldn't tell if there was tilt in the camera or not. That's the whole point.
Right.
What
While
do you
you're
mean?
watching
The
that video-
mountain is in the center of the camera. You know the distance to the mountain. What is the and how tall it is, and how tall is the observer? So what is the fucking angle?
The problem, Clem, is that they're not here to try to challenge what they have in their head. That's the whole
No,
thing,
it's
right?
tongue tying.
Gleam, do we live in
We actually are, right? We actually are.
Gleam,
Shut
do we
up,
live in
I was in the middle
Euclidean
of fucking
geometry?
bio.
Do we live in Euclidean geometry? Gleam,
No, that's a
essentially?
man-made concept to describe reality.
Right.
The
Do we
effect,
describe
by
it
the way,
as Euclidean?
Some people do, some people don't.
Do
We don't
you
see in
describe it
Euclidean
as
geometry.
Euclidean?
No.
I'm not partial.
Right, so we can't get straight answers. Okay, that's fine. If we can't proceed.
No, in science, yeah, you look at all options and you do not cancel out any option. Have you actually discredited the hyperbolic perspective then? Yeah.
No, the video describes a non-Euclidean geometry, so that's
That's
why
what
I'm
I'm saying.
getting at. Right.
Yeah.
So his thought experiment is based on not reality. So again, another reason why your video is retarded.
So spherical geometry is not reality.
No, spherical geometry still follows Euclidean because the surface of a sphere is still Euclidean two-dimensional space.
Oh.
But it's all right. We can proceed. If
So
you
that
can't take a
so
stance,
that
then
whole
you can't take
that
a
whole
stance. That's
thing
fine.
about it swapping over from Euclid to spherical maths didn't happen then.
Yeah, what's wrong with that?
Okay,
What's wrong
I
with
must have misunderstood that then.
Yeah, what's wrong with that? Because your video provided non-Euclidean geometry, so that's why
Yeah,
I
it's
brought that up.
Minkowski. It's actually Minkowski space-time. You're not aware of that?
Yeah, that's perfect. We can obfuscate to something else. That's fine.
No, that is exactly what perspective space is described by.
Right,
You've
right.
got Euclidean space embedded in Minkowski space.
You got it, Gleam. You got it. If you say enough words, maybe it'll connect. You're right.
I can cite it, but you'll just deny it.
Gleam,
I'll pretend.
I don't think that they've read the optics papers that you have because they're acting like you're making stuff up.
No,
it's pretty obvious they don't know what they're
pretending
talking about.
Minkowski was only involved in relativity. It's a geometry. You don't understand. His framework was a geometry. You're idiots.
Gleam is actually correct. The paper that he cited, which is talking about the change in this, what we
I won't have it. No, I don't. No, I'm not correct. There's no way I'm correct. You're always right.
The citation that you offered is actually correct to do with the change in the relative perspective effects of an angle. If you have a wide angle lens, and in the certain circumstances, you can get this effect due to the fact that it's quite a complicated effect due to the fact that cameras have a flat sensor. But this is not relevant in the panorama case, where we've got a distant object and you've effectively got a telephoto condition.
Well, Ruhif wasn't talking about that.
The actual citation you offered is actually correct, but you've misapplied it, as you always do.
No, Rumpus, you've just misapplied it because Ruhif said he was talking about the photo, not the panorama.
Okay,
And you
so
just
the
applied
same
it to
thing.
the
They're effectively
panorama.
the same thing. The panorama and the photo, which are distant objects, have the same rules to them. The rules that you're talking about, where you have these effects, where you do get a change in the perspective effects of say a building when you which are close to, and your objects are close to you, and you change the tilt of the camera because of the flat.
Shout out Science of Science, $5. Thank you very much. Rumpus is the globe champion that creates more and more flat earthers. The guy is insane. He definitely has a unique way of thinking. That's for sure. Thanks, Science of Science. Much appreciated.
Which is round the surface of the.
Look at the videos. The
surface-
video's showing that you're wrong.
Could you please stop interrupting me? The light-sensitive surface is spherical, as in an eye. You do not get the effect that they're talking about. But with a flat sensor in a camera, you do get these changes in the apparent shapes, the same when looking at towering buildings. So that the thing that he was citing was applicable to certain situations.
You need to
to
read
do
the
with
whole thing, I
cameras.
think.
But it's
no,
not
no, it's not.
But it's
No,
not applicable
I think you need to
the
read the whole
situation
thing.
that we're talking about of a distant image with a small
Incorrect.
field of view.
Incorrect. You need to
No,
read the whole thing, please.
No, you
Incorrect.
don't understand. You don't understand that when it's
Yeah,
applicable
you
and
can
it's
just keep repeating that, but you
I
just
will.
literally said I didn't understand, and then you've
don't
literally read it and come back and
don't
said
understand.
Gleam is correct. Actually,
You know the citation was correct. Okay, you're correct that the citation is correct, but you've misapplied
my
it to the in the
fucking
context of our
God.
discussion.
Yeah, whatever.
Anyway, I'm gonna
you were
go to
having a different discussion, obviously.
No, you missed it. Anyway, Fed was claiming to us that I've drawn something
Yes,
on screen.
go
I
to
was going
this.
it's
You
2 foot
chat
wave
shit.
business. So if you can see what I've drawn on
Well,
screen here.
yeah,
I've got,
before we go to that, because we will in a minute, Data, I've been showing your demonstration. You want to tell us what it is?
Yeah, definitely.
And I have a question.
Hold on, Chaiki. Data, do you want to tell us what it is?
It's a video. I'm talking about the video. At what time in the
Yeah,
video?
but can he explain what it is first, and then you can ask questions, Chaiki?
He said.
Yeah.
Chaiki,
thanks,
drunk.
Chaiki.
Shut up.
Go ahead, Data. You there? All right. Well, maybe we'll come back to it. Rumpus, we'll go to yours then.
You can back to I mean you can do it. Okay, so
Well-
my diagram here. We can go back to Fed.
Wait, Rumpus. He said that he showed the shorter objects.
He's not there, Chaiki.
I don't care if he's not here.
Well, we'll come back. We're not going to have the discussion about his shit without him. They'll come back, man.
Okay, well, hang on, Chucky. Wait for him to come back and we can discuss it. He claimed, this is the point about, from the video that I can just see, he's drawn something on the floor, which is absolutely irrelevant to the discussion, just like Glean gets confused about the horizontal and vertical objects. Here's the diagram. Here's the claim that we make. You can see how I've got an observer on the left-hand side with a camera, and he's higher than a wave. This is a wave, by the way, this blue block. And this is an object in the distance. And the claim that Fed made is that this 2-foot object can somehow obscure the bottom of the object in the distance. And I said the only amount it can obscure is 2 feet's worth. And as you can see, from this position here, when you're above the object, there is a straight line of sight to the bottom of the object, and it will not be obscured at all. The only time...
Assuming a flat Earth, Rumpus. Assuming a flat Earth.
Yeah, assuming a flat Earth. And therefore, yes, because he's trying to claim that on a flat Earth, that things can obscure things from the bottom up. The only thing that can do, you get this wave obscuring it, is when the wave is right next to the object, and it can only obscure 2 feet, i.e. the height of the wave. Nothing more. You should be able to see. Now, his video that we just caught a snippet of, has something going along the floor, which is absolutely irrelevant to this discussion.
No, he puts 2 bits of paper on top of it. You seriously can't pay attention. You've got ADHD,
We're talking
mate.
about a 2 feet vertical wave. That's the subject of discussion.
He puts a piece of paper on it, Rumpus.
Going horizontally, he doesn't understand the issue.
He does it vertically, Rumpus. You are seriously jumping the gun. Have you not been watching it?
No, I haven't seen it. Well, he's not.
He puts that bit on the floor, and then puts 2 bits of paper which stick up. You are seriously such an idiot.
And
Right,
at
but
what
what's
point?
his point, Glenn? What's his point?
And at what point the
convergence.
short piece of paper hides the more than its height, the higher piece of paper?
Which it doesn't. It cannot. Unless you're
That's
lower.
exactly the
Unless you're
point.
lower
I
than the
clearly
smaller
demonstrate. I clearly demonstrate it hides the bottom, and as I increase my distance, increase my zoom, I will increase the convergence point, which makes it appears to cover the bottom. I literally demonstrate it.
Gibberish.
If your camera is above the little piece of paper, it will never hide.
It's on
more.
screen now.
I demonstrate it, you morons. I demonstrate it in
No,
real
you
time.
have not.
You've drawn
It's on screen now. Talk it through. Talk it through.
Data, tell us what you're trying to demonstrate here.
Rumpus.
Let's hear Data describe what he's trying to demonstrate.
What I have done is I'm basically showing you the foreshortened compression effect. That basically when we increase in height, why we see an extension outward.
On
the same
floor.
principle. Let me finish.
It's not vertical, is it?
Wind your neck in. He's just about to get there.
Go.
So listen, I do on a horizontal plane, I do an example of a vertical and a horizontal foreshortening effect on a horizontal plane. And then what I do is I put 2 vertical pieces together that are perpendicular to the horizontal to also show you the foreshortening effect.
Well, do it then. Show us that.
It's in the video. It's in the video.
I'm sharing the video,
Let
guys.
me finish.
Well, move the video to the point where you do that.
Let me finish.
Rumpus, you're having a panic attack. Calm down. Shut your mouth.
What I
Put your fingers on it.
What I demonstrate clearly is the camera height is above the first object in the foreground and considerably a considerable distance above the smaller piece of paper. And as you notice, as I move away and I zoom in, the bottom of the piece of paper being lower than the camera height appears to ramp up, rise up, and cover the bottom of the object in the background. I demonstrate it clearly.
Okay,
That's
yes, flat Earth
Bottom
Theta, you're
up.
right.
Ask,
you're right.
ask
So
questions of
you're
flat
right.
Earth
So
Theta.
guess
Ask
what?
him questions.
Guess what?
This is the
Guess
question.
what?
Flat Earth Theta. You're right.
Listen,
You're right. What you
morons.
described
Listen,
is what you
morons.
have.
Listen,
I'm gonna,
morons.
I
Listen,
know, but I'm
morons.
gonna ask you a
Let
question.
Flat Earth Theta finish.
Let him
Listen,
finish.
morons. Listen, morons.
Yeah. Go ahead. Special
Again,
treatment for Flat Earth
listen,
Theta. Go ahead.
morons. Listen, morons. Your argument states that the camera height cannot be above the object in the foreground that's lower than the object height, and your conclusion is it will not block the bottom of objects in the distance.
No. So I will
prove
it's another case of Flat Earth Theta has a wrong premise.
and demonstrate. I prove and demonstrate you guys are wrong. I demonstrated.
We know things.
I demonstrated in real time.
We obscure some of them. We know.
I demonstrate bottom up.
B-ball for life. You sound like you're 50 feet away from your mic.
Yeah,
I
demonstrate in real time.
Can we respond now, please? Because you have given it, and you presented a false premise, and I'm trying to address.
Why can't I
if Rumpus is going to be muted, if Branch is going to be muted, all these people are going to be muted. Why isn't Flat Earth Theta?
Why can't I conclude my statement?
You explained what you did, and you have a false
Bio
premise.
does. Why don't you just let him finish? Go ahead and finish it up.
Yeah, you're right. Special treatment for Flat Earth Theta. Go ahead.
Again, there is no special treatment. What it is that just so the audience can hear, the globe argument states that objects below the camera height can and will not bottom up obstruction to any object in the background.
I didn't say that. Look at my diagram.
Let me finish.
I shouldn't have unmuted him yet.
Let me finish. In every orthographic drawing of Rumpus's demonstrations, he claims that the objects lower than the observer's eye line do not ramp up, that do not cover the bottom of objects in the distance, when I clearly demonstrate that the opposite takes place.
Perfect. So
I
I'm going to
clearly demonstrate that is. So hold on.
So you're not done. So Rumpus is insta-muted. Flat Earth pauses, and I have to stop now.
Actually, I think I'll just mute you.
Data's finished. Data's finished.
Stop getting emotional.
Go ahead, Data. Finish up. Hurry up.
If I demonstrate clearly the opposite of what you suggested, I want you to give me an example of what I'm doing there that's incorrect, because all I'm doing is having a camera above the height of the first object and the second object in the distance, and all I do is zoom in over a level plane. And what do we have? We have bottom up obstruction. Thank you kindly.
So all you're doing is zooming. You're not physically moving the camera back and forth.
Bio or Rumpus.
Is that right?
That's all it is, dude. That camera height is higher than both of those pieces of paper, and yet when I zoom in and I move away, the bottom-up obstruction of the object in the background increases.
So you are physically moving as well.
I'm physically moving away, just as perspective would. As you would move away, there would be a convergence. There would be a bottom-up obstruction due to the compression of the foreshortening effect or perspective effect or angular limit into the diffraction limit. That's what it's all about. And I demonstrate it clearly.
Okay, all right. Now I'm going to let them respond.
Thank you.
Shut the fuck up, or I'll mute you.
Right. My diagram showed exactly what he's talking about. I said 5 minutes ago in my diagram that a wave of 2 feet high can obscure a maximum of 2 feet of a distant object. And he's now just repeating that. What we're dealing with when we see bottom-up obstruction with a wave of 2 or 3 feet high, we see thousands of feet of mountains disappearing. So his demonstration is absolutely irrelevant, and he's just agreeing with what I drew.
Right. The false premise that I was getting at before is that globe earthers don't claim that something that's smaller than your observer height cannot obscure something in the distance that is any height. No one's saying that at all. But Rumpus, what he just said is 100% correct, as well as his demonstration, in which the perspective is that on a flat plane, that small object can only obscure the height of that small object, and that's it, nothing more.
Correct.
So this is another case of Flat Earth Theta having the false premise and then coming to a false conclusion.
I demonstrate
I think Bio was speaking. I think Bio was speaking.
I demonstrate clearly the opposite of what you guys are saying.
No,
and in fact,
hold on, guys. Let me say something now.
The farther I move, the farther I move away.
Hold on. Data. I think that they're right. I don't think they make this claim. This is all about angles here. I mean, this is just common sense.
Yeah,
that this is
and
going to
they
happen
claim
because
that
you're
objects-
changing your angle between the small one in front and the big one. Here you're closer, you're looking down on the front one, and you have that gap in between them. And then as you move away, your angle to the front of that in relation to the back one changes.
How is that any different than standing at the shoreline and having a 3 or 4 foot wave that's below your eyesight? Let me finish. Let me finish. There is no different of having a 3 or 4 foot wave below the observer's eye line at a 90 degree. And as you move away, the wave does the exact same thing, which is appear to wrap up, which is appear to ramp.
Rumpus, you can have 2-foot waves, can
and
they?
you can have exactly. So I demonstrate that yes, you can have objects that are lower, the observer height, ramp up over a level plane, blocking the bottom. In other words, you can
only
have
by
a
the
wave
height of the thing
block
that's doing
the bottom of
obscuring.
both.
So if you've got a
That's
2-foot
what it
wave,
is.
it can only
So
obscure 2 feet.
if you have a limited angle to the bottom up obstruction,
a 2-foot wave can only obscure
Okay.
2
you
feet of
have
the object.
You're
It
not
can't
helping,
obscure
Rumpus.
thousands of feet.
You really aren't.
if you have a limited angle for a bottom-up obstruction, which I can demonstrate on a level plane using zoomed-in
ignoring everything
camera
we're saying.
lenses, then you can see that convergence happens. So the same process happens with the lens. So there's no reason to think it's
You're
Earth
just
curve when you
denying
can
everything we're
duplicate
telling
it
you.
with
You're
optics.
just ignoring us. We've
Yeah.
told you that we accept that an object in the front will obscure at maximum the height of the object. So you've got this little thing here.
So that
and
2-foot
say,
wave.
Hold on, let me
ask
finish
you a
for once.
question,
You've
Let
been
him finish,
speaking
Data.
close to the
Let
last
him
5
finish,
minutes.
Data.
Right. So we said in my diagram before you started speaking, I said that an object in the foreground, if the observer's above it, can obscure up to the height of the object. So if you have a 2-foot wave, it can obscure 2 feet of the distant object. It cannot obscure the thousands of feet that we see obscured, and something like in the recent
Again,
panorama,
it can,
you see
and the
pictures of
demonstration.
Marseille, in the pictures of
can.
Marseille,
Data, hold
we
on.
have
And the
hundreds of
demonstration
feet.
shows
We
it.
have hundreds of feet obscured, and we do not have hundreds of feet of waves.
Yeah. Because you have an object in the foreground obscuring the object in the background. That
We've
object
just
in the
said, been
background.
through the fact it can't
that
obscure
object in
anything
the
more than the
background-
height of the object in the foreground. If you have
Again-
a 2-foot wave, it can only obscure 2 feet. You still
Again,
haven't
you are
understood
wrong.
this, have you?
Again,
Hold on,
you
that's
are
their
wrong,
claim.
because
Data,
you're not.
you have not. If that's their claim, that the object in the foreground can't obstruct more than the height of the object in the background, you haven't disproven that part of the claim. I don't see it in this video.
Thank
if you
you,
have.
Brandon.
So, yeah. So what I've proven in this video is the
Sometimes you're
foreshortening
okay,
compression
Brandon.
effect.
We heard what you proved.
Oh,
The
I couldn't agree with you, right?
the foreshortening compression takes place, the convergence takes place. It also shows you that objects below the observer's height at a distance away from the observer will appear to ramp up into a point where
You've
it can
changed
block
the
the bottom of
subject.
objects.
Fucking no.
I
You
didn't
keep
change the
changing
subject at
it.
all.
Now,
I'm
haven't
trying to
you?
tell you what I displayed.
You've changed
If you're
the
telling
subject.
me
The issue we were discussing, you've just changed it completely.
didn't change no subject, dude.
You
No, I didn't.
have. You said
at all.
that we were wrong.
Not one
in
bit.
No, he
saying-
hasn't. No, he
I haven't
hasn't.
changed. I haven't changed
Yes,
it at
you
all, dude.
have. You said
What I
you're saying
demonstrate
that an
is-
object in the
listen,
foreground can obscure
what I
great
demonstrate
wads of
is
the
what your
background. And we said,
orthographic
no, it
dra-
can't. It can
what
only
I
obscure
demonstrate
the size of the
is
foreground
your
object. And you
orthographic
claimed you had a
drawings
proof
don't
that would show that it could
represent.
obscure great wads of background objects, and it doesn't do that. It only obscures
does. It
by
wa-
the height of
100%.
the
Why don't you let him
foreground
get it out?
object.
Once
Data,
again,
can you
once
show
you
us the
get to a map-
orthographic drawing that this
Let him get it out. Let him get it out,
that this
Rumpus.
falsifies?
I can help, but I need Rumpus's help on it.
How about Data draw a line on the background object the same height as the foreground object?
Yeah, that would be good.
I could present something.
So, gentlemen, here's what you're negating. Do you agree that all objects will appear to ramp up into a neutral point of the eye and diffract?
That's,
Do you believe
that was just gibberish? That was just gibberish. You just made that
Okay,
stuff up.
so
That
you
was
don't.
not based on
I
geometry.
agree.
Right. So a vanishing line
that
or
is
horizon
real.
line
That is
is not
perspective.
caused by diffraction, then, right?
No,
Yep.
diffraction's got nothing to do with this. You just
Right.
made that up.
Okay.
You don't understand
So
what diffraction
I can
is.
demonstrate. I can
No,
demonstrate as
we
well.
know. Don't deflect now.
I can demonstrate as well.
changed
that
the
you, can,
subject
you have a
completely, by the
vanishing
way.
point and a vanishing line
But
based
we
on
weren't
the
talking about
observer's height
vanishing
and the
points,
distance
were
to
we?
the object.
You've changed the subject completely. We were not talking about vanishing
How do you get a
points.
vanishing point? You need a convergence, right? You need an
Nobody
angle
cares.
to
Not
it to
called
converge,
convergence.
right? So when
You
I
don't
have two
understand
It is
objects,
Rumpus. Stop being.
when I have
pedantic.
two
No,
objects
he
in the
does it every
distance,
fucking
He's
time.
when I
changed the
have two
subject, Gleam. He's
when I
changed
have
the
two
subject
objects
completely
in the
because he's
distance,
realised
He
when
hasn't.
Brandon
I
didn't
understand
agree
I
with
where it
him,
haven't
is.
he
changed the
realised he
question.
was talking
I haven't
bollocks.
changed
He
anything.
does
You
what
All
guys
he
right,
just
all
normally
right,
want
all
does.
to
right,
do
all
it.
right. This is
Change
not
the
getting
Whenever
us
you're
subject.
ready, I'll
anywhere.
go through
I
it
think
with
I
you.
heard Pebble in the pond say that he had something to back that might shed some light on this argument, an observation or something. Did I hear you, Pebble?
Yeah, I got something to show.
He's got something to show. Let's see what he's got. Maybe this will clear it up. You're sharing?
Not yet. Hold on.
Okay. For those of you who don't remember, Pebble is the one who did the observations in the factory, opening and closing the door, letting the hot or cold air in.
All right, interesting, good stuff. It was good. That was good stuff.
Yeah.
Yep. Good inferior mirages. Well done.
Yep, good inferior mirages indeed.
Set up.
You're sharing now?
Yeah, I'll just show this first, and then I'll go to the real
Gotcha.
life observation.
Your mic's a little low, so maybe just speak up. You should be okay, but I got your screen now.
Better.
Yeah, that's better.
All right, so here's the setup, side-out view. I have two cameras in this observation. Distance between the cameras, 30 meters. And then blocks on the floor. And sides of blocks, 48 by 98 by 315 millimeters. And they are spaced out.
Sorry, just to clarify, is the camera above these boats?
It's set on the floor. I'll go to the real.
So not above the
Are they
boats.
floating above the blocks? I'm a bit confused.
Yeah, calm down. Let him explain it, right? And don't jump the gun, because you're asking loads of questions that he'll probably answer just if you give him time.
Question's been answered. Question's been
Yeah,
answered.
let him go. Let him
Side
go.
out view. Right here. There's the bird's eye view. So I got blocks on both sides of the cameras, and every block is 40 centimeters apart from each other. All right.
So I still understand. Are these pink and blue
clear?
boats above the blocks?
I'll
Of the
get to
camera.
real life observation, and you'll see.
So you've drawn them floating in space. I don't understand.
It's just a
Calm
diagram.
down.
He has a real world example. This is just a diagram.
Rumpus. You're
It's
having
a
a panic.
reasonable question. I don't understand.
we might
that they're
have an
floating
answer.
above the
Wait,
blocks.
have patience, mate.
We might have an
You'll
answer
see
in a
it.
second. It's just a rough diagram. Don't worry. Your diagram looks
All
way better
will
than
come
mine.
clear with time. Time alone is the holder.
Let me just change.
I don't understand why you can't
here.
answer a simple question. Are the blue and the pink?
He just
blocks-
said, "I'll show you." Just calm down, Rumpus. Seriously, you pissed. You're taking the piss.
Just such a simple
You're
question.
literally
It's
like a
easy
kid
answer, but
outside of an
someone's
ice
gonna
cream
come
van
up
going,
with
"Come
it.
on,
You're
be
guilty of it,
next."
Blaine.
All right.
Blaine, you're guilty of it now, right?
Well, I got the wrong video here, but
Right, so they're at ground level.
No.
Why couldn't you just say that?
I was
Jesus
just telling you I'm
Christ.
gonna go to the real observation, so just patient.
Yeah, voice did get kind of crazy for a second.
Just
It's a
calm down.
simple question.
All right, so here I don't actually have the camera here.
So your orthographic view does not reflect.
Just
what
let
you're
him pull it
saying.
up, Rumpus.
The
No, it's
orthographic
not
view you
Rumpus.
showed us does not agree with what you're showing.
God's sake, you're just constant minders going, "Oh, I want to interrupt everyone. I need my voice to be heard."
Says the guy speaking.
Yeah.
And the one interrupted.
Yes.
Hold up.
Unbelievable.
You are.
How can you not get the orthographic view in the picture?
All right,
to
so here.
agree?
Rumpus, relax.
How do you know this is the real picture yet? He's just
He's ready,
getting
let's
ready,
go.
mate.
Let's go.
So they'll be floating, will they, in the next picture?
Calm down, Rumpus.
Pebbles.
You'll see.
Pebbles, let's go.
You don't like me bringing up valid points.
Calm down. No, you'll get them answered.
Shut up, Gleam.
I'm interested, but I'm hearing your voice going, meh, 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 but I can't
I was asking
concentrate.
a simple,
Do I have the right
reasonable
one on
question.
on Discord here?
So we just see a picture.
Yep.
From
We're
one
looking
end.
at a picture with the blocks and the boats. Yep.
Test 20 cam, 1 crop.
All right, yeah, sorry. There.
Oh, file name would have been better. You're right.
All right, now you guys probably have a video there.
It looks like it's potentially
Yes.
video. We don't see anything moving though.
All right. So here's from the camera number 1, pointing towards the doors, and that black spot in the middle there, that's the second camera at 30 meters. these wood blocks 40 centimeters apart from each other all the way across. And these blocks are spaced every 5 meters all the way to the second camera. Pink boat is at 15 meters. Blue boat is about, hold on, where was it? Is
Looks like about 20, maybe 25.
7.5 meters about from camera number 2, 7.5 meters from that. And camera number 2 is the one at towards the doors here. And then this block over here on this right side, this is the block I've used before, 2 centimeter spacings between these black and clear lines. And the first line is a clear one. So this first black one is, the top edge of it is 4 centimeters off the floor. So that's the height of that block. You can kind of compare that to what we see in the foreground here. And on these blocks, the top part of this black line is just about where the center of my camera lens is. So it's, I tried to align it so it's eye level. And yeah, this is what we see. And I do open the doors here, and temperatures was, inside was 21 degrees Celsius and outside was about 25, 26 degrees Celsius. And I kept the doors open longer than I usually do. But there isn't really much any
Can you play the video again?
garaging that happens. I'll just bring it back and forth because I can't. Let's bring it back here. All right, so this is before the door opens. Door opens and closes. Oh, and that block on the right side fell over when the air rushed in, so that's why it's tumbled over.
What are the changes that we're meant to see?
Oh, that's the thing. We don't see any obvious changes when the temperature is, because before I've done this when it's a lot colder outside, but now I've had a warmer temperature outside than it was inside the factory. So we don't see the miraging effect that we've usually seen on my older, earlier footage. But yeah, this kind of shows like the perspective part where you can have an object. Hold on, let me bring it back. There. Now this object is 98 millimeters high, and that's 5 meters from the camera. This block over here, the top line there, is 20 centimeters off the floor.
I can't see your cursor, by the way.
Are you referring to the ladder, the black line ladder on the right side, kind of in the towards the door?
Yeah.
Okay.
So the top black line is 20 centimeters off the floor. And I think the very top part of this block is 40 centimeters. I'm not 100% sure about that, but it's somewhere around that area.
Okay.
So this
Does anyone know
like
what the
perspective effects
goal is of this?
and angular sizes.
So I think he's trying to tie this with the subject of what Flat Earth Data presented, and the only problem that I would have is that the observer is below that smaller object.
Yes,
Why don't we let him describe why he's showing this to us? Well, Pella,
No, that's fine. Yeah, of course. Yeah, sorry.
Yeah.
Are those two cameras the same?
No, they're different cameras. One was a Canon, the other one's a Nikon.
Can you see the lens is about the same height? The center of the lens, the same height for both?
On the camera number 2, the lens height was like a millimeter or 2 higher when I placed it on the floor.
So we can tell what the center of the lens of the far camera is, right? And what is eye level.
It's also not a pinhole camera. Like the actual size of the aperture is going to change things as well.
Yeah.
It's going to be a relevant factor in this.
No, I'm just looking for eye
Hold
level.
on. We still haven't given
what
him
is
a
the
chance
point?
to-
Oh.
Yeah.
The top.
Yeah, it's confirmation. It's confirmation.
Blocks,
But nothing
on these
happens.
blocks, the top.
Yeah, he's doing it at different
Let him explain
times.
it. Let him
Guys,
explain
let
it.
him. Yeah, it's his observation.
On
Let's
these
hear what he has
blocks
to think.
that are placed every 5 meters, the top line, the black lines on these blocks, top part of it is where I have aligned the camera lens, like the middle part of the lens. I measured that to be hold on, where's 3.6 centimeters off the floor. So that's the top part of the black lines of these blocks. So that's where I tried to align the eye level of the camera.
Right.
Seems to get like you
we're,
got
we're
pretty
all
close
sitting
with
here
that.
wondering what the point is, by the way.
Yep. We've no idea what point you're trying to make.
I understand it. It's called science. What he's done is you just congratulated him on his other one, showing that in a cold temperature, when cold hits warm inside, a vast experience happens. But now when he does it, and it's only 4 to 5 degrees, barely nothing's happening.
Yeah, we know.
So he's just demonstrating his findings.
Nothing happens.
Yes.
So he's showing us a video in which nothing happens and demonstrates nothing. I don't understand.
You would
hold
not
on.
understand Rumpus.
He is trying to get it.
You guys, please, let's. Pebble's just taking his time to get it out. Pebble, say that again.
All right. So to me, this shows the angular size change when objects go out into the distance, because all these blocks are the same height, yet they get smaller out in the distance. And to me, this shows that an object in the foreground can
bigger than the
obstruct
one in the background.
object behind it.
You've just
right here,
discovered
it's not in
perspective.
front of it, but you can see that if
My
I
God,
would
I don't
move it off to
believe
the
it.
side, it would
You've
block
done this
that
demonstration to show
block.
that things
God
are
dang,
wrong.
you know, the guy did some actual work, and you can't even give him the respect to just hear him out. Okay,
No,
at
it's a
least
good
if
job.
you're going to
It's
trash him,
Pebbles,
just
right?
wait till he's done.
It's Pebbles, right?
Yeah.
Pebbles. Yeah, man. So your observation can be done at various scales over a distance of 50 yards, 100 yards, 200 yards, just with different size blocks. It's a repeatable demonstratable observation you can do at scale. It's the same with my observation. You can do it at various scales, but there's one common denominator between your model and my model, which is everything is in straight lines and angles, right? And that's why it's scalable.
Yeah.
If you're going to measure dip, drop, or curvature at such short distances, when you scale it to do scale observations, none of the discussions take in consideration over a distance, let's say 1/100,000 scale of a 2.5 centimeter drop over 6-7 feet, right? I don't see any of those observations taking place. Every single observation is using straight lines and angles, so like we observe in perspective delineation, which basically Pebbles is doing a perspective delineated observation here, and indicating between two temperature differences, or at least seasonal temperature changes, there's considerable refraction effect depending on those environments. So Pebbles right on. Do you guys understand that even at my demonstration, which is the observer height is above both objects, but the pattern and consistent pattern that comes up is the convergence. In other words, it doesn't matter what's in front and what's in back, the bottom-up obstruction will occur optically based on this angle of light to the camera optics using zoom. Do you guys follow that it's duplicatable?
Are you claiming that your small bit of paper in the front obscures more than its size of the back bit of paper? Is that your claim?
So my claim is this, is that I can demonstrate based on my position of my camera, which is distance, the height elevation stays the same, that there will be a convergence, and that foreground object will continue to rise up into the background object and cover and slowly hide more of it. Yes, that's what I claim.
Will it block more than at the height of the little piece of paper?
It will at the point of
Okay,
convergence.
that's your
of maximum.
claim. You did not demonstrate that.
Yes, what I can demonstrate, and I've already done it before, is because of a vanishing point, which I cannot translate because it's an optical convergence. But what I can do is I understand what it does, which is meets a maximum angular limit in the neutral point, which no object at the bottom part will show any detail, and every object above it that shows detail will appear to have the bottom of it cut off. That I can demonstrate by having a supposition of a piece of paper cutting off 50% of the angle of the camera. And when I do that, I can have all objects appear to go down over the edge of the curve. Now,
Does
if
everyone
I
else
understand
tune out when he
vanishing,
starts on these rants?
if I understand vanishing point correctly, this is the point of diffraction where no information can be resolved. The foreshortening effect, if you will, where the information is compressed. Now that will create that, if I did that red tape over a period of a longer distance and moved away, it would create a massive red thin line. Just as the same example as the horizon that we see as we move away from objects. If we have an unobstructed horizon, it will appear to create that convergence vanishing horizon line. That
Have you
is the
finished?
angle of light
Hurry up.
subtended to the eye at its maximum resolvable detail. That's based on the angle to it. That's it, which you can demonstrate with horizontal planes and vertical pieces. The same convergence takes place in all scales. I'm done.
Rumpus,
Right, okay.
let me ask
Your
you a
video
question.
does not demonstrate hiding more than the height of the small piece
Let
of
me
paper.
ask you a
The end.
question, Ruhif, because you've got these blocks in front. I'm trying to understand what you guys are saying. So you've got these blocks in the front that are this big, right?
Wait,
All
we
these
want to know
blocks
what
are the
Pebble's
same.
point is.
All these blocks are the same. So this block's the same as this block, is the same as this block. This obviously covers a lot more than these ones in the distance. This one down here is tiny. And it's
I
higher.
can't see
So
a
I could
cursor.
shrink these blocks in the front down. And they would still cover the ones in the back, right?
You could shrink them down a little bit, yeah. We all agree that objects
that would be
appear smaller in the distance, right? Everyone agrees
So
with
that would be smaller. That would be a smaller object in the foreground blocking a larger object in the background, would it not?
The biggest difference is that the observer height is
Yeah, it would,
lower
'cause look.
than the object height. So we agree. If your observer height, if your eyeballs are below the height of a small object, that small object can obscure the entirety of a large object. Of course, the initial discussion was the observer's eyeballs, the observer height above a smaller object. That smaller object could not physically obscure the larger object on a flat plane.
By any more than the height of its small
By
object.
any more than the height of it. Correct,
Yes, it can, and here's how you have to look at it.
No, it can't. Demonstrate
Let
it,
me
Data.
finish.
Demonstrate it.
Okay, so I already have demonstrated.
No, you
just went one
haven't.
ear and out the other. So I can demonstrate it by cutting off the neutral point of the camera at 50%.
Go
Any
fucking
object
do it.
along that
Stop
neutral
talking.
point will appear to converge down into it. Now, you have to understand that all those objects you're witnessing in Pebble's experiment will converge. The material matter will be there and will block the light of objects. But the best part about it is it will rise up and compress into a diffraction point.
No,
all of
it
that
will not.
information, all that information
No, it
is
won't.
foreshortened. All that information is foreshortened over the distance compressed.
No,
into
it
an
will
angle.
not.
It'll create a vanishing point and a vanishing line or a horizon line. That's what it will do. That material is still going to obstruct objects in the bottom of objects past that point of angular limit. That is what's demonstratable here. It's what's repeatable in observation. You guys keep ignoring it. Just so you know,
Fucking repeatable. You didn't
ignoring
present it once.
There's a reason why.
You keep saying I can demonstrate and you don't.
Do objects at a distance converge into a vanishing point? Yes or no?
No.
Yeah. There you go.
I'll say yes,
That's it.
Data. I'll say yes. I'll say yes.
Oh, yeah. So wait. So is that a genuine yes? Because Chaiki just said no. So why the fuck am I debating you at this point? Chaiki's disingenuous.
Train
100%.
tracks appear to meet, right? Train tracks appear to meet.
All objects, doesn't matter. Listen, just for shits and giggles, point your eye anywhere and walk away from two objects. It'll appear. It doesn't matter where you put your focal point. It will converge into a point.
Yes.
So
Stop
all
fucking
objects.
yammering and get to a point.
And the small object will disappear before the big object.
Ding, ding, ding. But well done. But the whole point is that a larger mass of Earth and hoses and a conjunction of that will form a banding line because we're on an extended plane, as the tape demonstrates. That over the plane, if I have a territory, even if it's a millimeter of information above the horizontal plane vertically, it still will have a foreshortening effect. It will still have a compression effect. Let me finish. To highlight the compression effect, the foreshortening, the angular limit, the diffraction point comes next. Do you understand? The apparent rising, Ruhif, come on, buddy.
Right. Your video did not demonstrate that the small piece of paper hid more than the small piece of paper's height of the back piece of paper.
Okay, so in your ball model, you claim that
No,
objects are hidden bottom up.
do you accept that or not?
So
do you think
the
you
problem-
showed more?
The
Do
problem
you think
is
that
with
do you think the small piece of paper hid more than its height?
it can at a longer
No,
distance.
it can't. Did you
longer
demonstrate that it
distance.
can in your video?
Yes, I demonstrated the
No,
concept
you
that
didn't.
it never. Yes, I did. I demonstrate the concept that it will rise and cover the bottom.
Yeah, we know.
That's at that
Yeah,
distance.
yes, we know.
That's at that distance. Now hold on. I have a next question for you. If I increase my distance, what happens to that material if I increase the matter size or the size of it, but I increase my distance?
Yeah,
And I keep moving away.
amount that it
Will that
hides.
hold on.
Pebbles,
Will that
thank you
bottom
very
piece
much. Appreciate it.
Will that smaller piece continue to rise up as I move away?
Okay, we're going to call it a night. Thank you very much for tuning in and checking out the show. Shout out to Rodney B, Silent Zero, and the Science of Science for their super chats. Thanks, guys. Shout out to the channel members. I see a few of them in chat right now. Godzilla37, Raichi, and I'm sure there's more. Scrolling up. Thank you, guys. Appreciate that. And we'll see you tomorrow. Don't know what we'll be talking about. I'll try to find something interesting. If you got any ideas, go ahead and hit me up. And we'll see what we can do. Yeah, that's it. You guys have a good night.